All right, good morning, everyone. It is officially 9 o'clock here in Wisconsin anyways, and so time for us to get started with our webinar here. We've got a nice crowd joining us today. Thanks for spending your time with us this morning. We're very happy to welcome you to Cover Crops and Water Quality, a multi-state webinar featuring the work of Discovery Farms programs in Wisconsin, Minnesota, Arkansas, and Vermont. My name is Amber Raditz. I'll be the moderator for the day. I've been a co-director for the Discovery Farms Wisconsin program for the past few years, and now I'm a program manager for our newly formed Agriculture Water Quality program at the UW-Madison Division of Extension. The success of the Discovery Farms program in Wisconsin and demand for agricultural water quality information has driven the formation of that program and the increased capacity that will come with it. This multi-state effort is in place to provide farmers, farm advisors, and interested stakeholders with credible water quality research information. First, I'll share a few housekeeping things before we get started. We definitely encourage questions and discussions from you. If you have content-related questions for the speakers, we want you to put that into the Q&A box, which is found at the bottom of your screen. It looks like two kind of conversation bubbles. And if you have questions related to logistics, whether they're technology issues, questions about CCA credits, I see some are already in the chat, agenda questions or any other logistics, we'd like you to put that into the chat box, which is just the one conversation bubble there, and we can address those separately from the Q&A for the speakers. Another nice feature within Zoom webinars is that you can, if you see a question in the Q&A that you agree with or also have a similar question, you can kind of upvote it so that we make sure that it rises to the top and we can make sure to get that answered. Also, if you would like to receive CCA credits for your time here today, we'll show you the QR codes at the end of the session. And at that time, you can scan the codes from your phone to register for credits or put your CCA number in the chat and we can register them for you. Any questions about that, make sure to put them in the chat. So the format for today looks like each state will have 40 minutes of presentation time, including answering questions. Each speaker will answer questions at the end of their talk. I'll moderate those questions from the Q&A. And there might be some time at the end of the session as we're getting close to 1 o'clock for questions, but we encourage you to really ask questions right away during the speaker time and just to make sure that they get answered in a timely fashion. And again, we also want you to use that Q&A feature to vote for questions that resonate with you, because this time we want to make this time really worthwhile for you. So first, before we get started with the other speakers, I'll provide just a brief background for you on the Discovery Farms program if you're not familiar. And then we'll kick off with the other Wisconsin speakers. We'll start. So Discovery Farms was first established in Wisconsin in 2000, and it was formed really in response to a call from the agriculture and environmental communities for enhanced farm research in the area of water quality. Farmers volunteered to host water quality monitoring stations in Wisconsin to better understand the dynamics of runoff timing, the impact of agricultural management, and the influence of weather. Over the years, programs have been added in Arkansas, Minnesota, Washington, and Vermont. Representatives from each state pursued the determination of Discovery Farms, which is actually a registered trademark, because of the positive response to the work of the program from farmers, farm advisors, agency partners, and water quality stakeholders. Each Discovery Farms program has to include the 3 pillars of Discovery Farms in their programs, and those pillars include farmer leadership, credible water quality research, and communication of results. For the Wisconsin Discovery Farms program, farmer leadership occurs through our steering committee, made up of representatives from agricultural and environmental groups throughout the state, and from the farmer participants themselves that end up playing a really key role in communication of results and articulating the value of on-farm research to their state and local communities. Today, you'll hear relevant research and information from a variety of speakers. Cover crops have been and continue to be a hot topic in conservation, and we don't have all the answers today, unfortunately. However, we do hope to provide you with enough bits and pieces that you can feel a better understanding of the issues and the ability to adapt and apply today's information to your own situation and learn a little bit about how we're all working together as a multi-state team to try to continue to answer more questions. All right, with that, I think we are going to go ahead and get started with our Wisconsin speakers. So our first Wisconsin speaker is Matt Ruark. Matt is an associate professor in the Department of Soil Science at the University of Wisconsin-Madison and an extension soil scientist with the UW-Madison Division of Extension. Matt is also the faculty advisor for the Wisconsin Discovery Farms program. So go ahead, Matt.
Awesome. Thanks, Amber. What we have structured for you today is kind of a two-part Wisconsin hour here with myself and Eric Cooley. So what I wanted to start with was just a little bit about some of the more simple work that we've done with cover crops in Wisconsin and how it ties and how it does potentially tie to water quality. And then Eric's going to follow up and talk about how we've scaled that up to looking at full edge of field losses. So here's some of our work in terms of fall cover crops, specifically as it relates to fall manure applications. So a lot of our work in Wisconsin connects to landscapes that look like this, right? So this is a field that has been freshly harvested for silage. It's a field that this is probably going to occur in early to mid-September, an opportunity for manure to get applied on this field and a cover crop to get applied or to get planted, but also not only to get planted, but actually to grow pretty well, right? So in Wisconsin, we're pretty far north. Vermont's pretty far north too. It can be a challenge to get cover crops established well late into the growing season or after a corn and soybean harvest. So a lot of our cover crop work focuses on corn silage, but it creates that opportunity, right? We have this fall application of manure. We know that's probably not going to be the most efficient use of the nitrogen in that manure. We're going to have some losses over the late fall through the winter and early spring. So can we use cover crops to trap some of the nitrogen? And so the cover crops that we've been looking at in the state are the first one is spring barley. Oats have also been tested, but spring barley represents that cover crop that will winter kill here. So it'll grow well in the fall, it will winter kill, and then look like this in the spring. So the trick with spring barley is, can we have enough growth where you're going to still try to get those conservation benefits in the spring, specifically, erosion control. So is the dead biomass coverage going to be enough? Some years, yes. Some years, no. This is kind of one of those perhaps in between where, well, it does provide certainly more soil coverage than no cover crop. Other cover crops we've evaluated here are annual ryegrass. The issue with annual ryegrass is it often grows back patchy. So sometimes it dies, sometimes it doesn't die, and often it'll grow back in this sort of patchiness. So it doesn't, that we've just kind of struggled with the consistency. And the last one that always does well is winter rye. So winter rye has always survived the winter for us in all of our trials. It grows really well, establishes well in the fall, and then continues to grow in the spring. So we do have some cover crop options. We're really kind of still limited to the grass cover crops when it comes to these fall seedings following corn stover harvest. And then the trick is, well, do you go with a spring barley and then not have to go out and terminate it, or do you want to grow winter rye, have it keep growing in the spring, but then have to go out and spray it down in the spring? So our interest was, so we're putting out liquid dairy manure in the fall, and then we're planting a cover crop, and we want to test, well, how much nitrogen is getting taken up by the cover crop, and then what's that effect on that next year's crop. And so what we did is we worked across 3 locations in the state of Wisconsin, kind of working north to south, and we worked across 3 growing seasons. So we had 9 site years of data. And the main thing is the nitrogen that's trapped in this cover crop in a perfect world, like we're looking for, well, we wanted to trap the nitrogen that was going to leach out anyway. Or does it also tap into some of the nitrogen that would be available to that next corn crop? And I want to just get some pictures in front of you because we're going to talk about total amount of cover crop biomass and trying to get a sense of what does that look like. So here's about 1,000 pounds of dry matter biomass. And you can see that there's, we have, it's getting pretty tall, but it's not necessarily, there's still a little bit of exposed soil, but it's still pretty good soil coverage. And the difference between 1,000 and 2,000 really is that completion of soil coverage. So sometimes it's not necessarily that the crop gets that much taller, but it actually really fills out and it's a nice dense stand of a cover crop. So, so basically that's the difference between 1,000 and 2,000 pounds of dry matter. So here is a worst case scenario of what I was talking about. So this is our Arlington Research Station in South Central Wisconsin. This is corn yield in 2017. In the previous fall of 2016, about 10,000 gallons of liquid dairy manure were applied. And then this is the winter rye cover crop was planted and compared to a no cover crop control. And so you can see in the blue, this is our response curve. This is corn yield. This is the nitrogen that we applied at different rates to the corn as urea. And you can see we're seeing our optimal N rate with no cover crop is about 100 pounds of nitrogen. So a lot of that manure did carry over to that spring and was available to the plant. However, when we planted a winter rye cover crop, it really tapped into that nitrogen, and we needed about 225 pounds of nitrogen to really maximize yield, right? So we needed about 128 more pounds of nitrogen to maximize yield following that winter rye cover crop. Again, this is our worst case scenario that we saw in our data. In addition, we also saw a little bit of a yield drag in terms of 7 bushel per acre that we couldn't make up for with just simply more nitrogen. Okay, so again, this is our sort of worst case scenario when it comes to using cover crops. We had a lot of biomass in this year, in that year of the winter rye, right? And it certainly trapped some of the nitrogen that was going to be leached out, but it also tapped into some of the nitrogen that was going to be available for that next corn crop. So for those that are using nutrient management planning, we assume a set amount of the nitrogen that's applied as manure is going to be plant available. But when we're using a cover crop, that cover crop taps into that available N credit from that manure. And so when we have all of these the cover crop biomass amounts, we have all of these sites, we have all of these years, and we can put together a graph that looks like this. And so at every location, we knew the amount of cover crop biomass. That's on the x-axis here. And we did the change in optimal nitrogen rate relative to no cover crop. And we see that this positive relationship where the more biomass that grew, the greater the change in optimal N rate, meaning the more nitrogen we had to supplement to maximize corn yields. Now, the data is pretty messy, right? It's not entirely predictive, right? We have an R squared of only 0.28. And what really is driving it, I graphed it a little differently here by the species. It's really these situations when we get cover crop biomass above 2,000 pounds, where it really starts to tap into a lot of that nitrogen and basically wiping out basically consuming all of the nitrogen that was applied from the manure. Okay, so what we can do with this data set is we've built we've crunched the numbers and we've come up with these recommendations where this is why that 1,000 and 2,000 pound pictures of cover crops were interesting, because we found generally if there was less than 1,000 pounds of dry matter biomass, it took up about 25 pounds of N, but it really didn't seem to affect the manure nitrogen credit. Generally speaking, this occurred with the spring barley. So it also is the fact that to have a low amount of biomass, you're going to have to plant a cover crop that winter kills, so you don't put on all that extra biomass in the spring. So in that sort of thing, spring barley, when it was less than 1,000 pounds, really didn't really have a big effect. When we had between 1,000 and 2,000 pounds, we're taking up between 25 to 45 pounds of N. In that case, it does tap into it reduces that manure nitrogen credit. So whatever amount of nitrogen you think that you're going to get from that manure, we'd recommend subtracting about 35 pounds from it. And then the big kicker was like when we had greater than 2,000 pounds of dry matter biomass, it took up more than 50 pounds of nitrogen, and it also appeared, at least in the above ground biomass, it appeared to take out the entire manure nitrogen credit, as it was as if that manure wasn't even applied. So there's pros and cons to this, right? Because the cover crops are going to take up, the cover crops take up nitrogen, right? It's what they do. And we want it to do that over the fall to achieve our water quality goals. But it does also, when we're applying nitrogen that we want to stay available to that next spring, well, cover crop doesn't know that that's what we want. So it taps into it anyway. And so we look at this numbers, anywhere, this is the above, we measured just above ground biomass only of the cover crop. And so, when we get to above 2,000 pounds of dry matter, now we're at about 60 pounds or greater of uptake. And that doesn't include any of the nitrogen that's still in the roots. And with a cover crop like rye, it does not decompose quickly in terms of its ultimate nitrogen release. And so it's not, that nitrogen does not become plant available that next year. That's all said, it's, overall, it's still much more beneficial for that cover crop, that nitrogen to be trapped in that cover crop biomass, and then leading to potential, building of organic matter over time and those sort of soil health benefits rather than be leached out. But what we also did is we also evaluated the right before planting, and at the time of, last year, it was at the time of cover crop termination, we measured the plant available nitrogen in the upper 2 feet of soil. And so plant available nitrogen being the nitrate and the ammonium. And here we're looking at the difference in the plant available nitrogen relative to the ground. So this is, every data point is one of the cover crop treatments, and it's the change in plant available N compared to the no cover crop treatment. So what we have here is that, and this is the change in the optimum N rate. So they'll basically showing that there's, when there's less nitrogen in that root zone in the upper 2 feet of soil at the time of planting, the more nitrogen we need to supplement. So this gets a little tricky, right? So often what we're seeing is that there's actually less nitrogen in the root zone following cover crop than without. But what we don't have is, we can infer some of this as a potential and a reduction in the amount that could be leached out, but we don't actually have direct amounts that were leached out. We know that there's nitrogen that's probably leached out in the fall, but we don't have those kind of direct measurements. So, but ultimately, it's really these cover crops do an amazing job of scavenging that root zone and pulling out nitrogen and plant available N from the soil. So inherently, we would think there would be less nitrogen leached out of the system. So ultimately, in our dairy systems, the recommendations that we're making here are really specific to this cropping system, where there's fall manure application, there's fall cover crops, and that next cover crop is corn. So it does tie into something very, very specific here, but also very meaningful, meaning that, this is a time, this sort of setup is one where there's probably the greatest risk for nitrate loss. And again, here's that picture of 1,000 pounds. So really, once we think about it, to obtain some of our conservation goals, we don't need 2,000 pounds of dry matter. We just need about 1,000 pounds. Anything that's going to get that good soil coverage, it's going to take up some nitrogen, but it's not going to have that detrimental effect to that next crop by taking up too much nitrogen, especially as it relates to fall manure applications. And Amber, you haven't said anything yet, but so I'm gonna do just a couple more slides here. One of the big things that we did in our original cover crop work is that we went a really heavy seeding rate. We wanted that cover crop to grow. We were using recommendations from the Forage World. We were putting out about 90 pounds per acre of pure live seed. So, well, sorry, let me, I'll come, actually, I'm gonna flip through. I'll just go to that. So what we've seen here is we also tested, well, does it matter what your seeding rate is? And so interestingly, in some work we did last year, we put out 30, 60, 90, or 120 pounds rye biomass. And interestingly, we didn't see much yield gain past the 60-pound rate. So, and only a slight dip from even going to a 30-pound rate. So all of this work is really up here, which is probably leading to a lot of that growth and uptake. We could probably start to hedge our bets a little bit by reducing some of that biomass by reducing the seeding rate. And that's also going to help with the cost of cover cropping. So as we think about these recommendations, as we think about these recommendations for using cover crops and the nitrogen management, the trick is we need to keep cover crop biomass low. I think that our recommendation is still, if the corn's that next crop, still wait that 10 to 14 days between termination of that rye cover crop and planting. That still generally seems to be the best effect. I would always recommend having a starter setup on your planter. So cover crops do what we want them to do. They take up nitrogen, but they deplete that root zone of available N. So supplementing a little bit of N at the timing of planting is going to help that crop take off a little bit better. In addition, there's no way to, you just have to, especially in our studies, when we're interested in using cover crops and using no-till in this sort of system, it's all about also the planter setup. So we saw some pretty bad failures in some of our locations just from poor no-till planter setup. So the better no-tiller you are, the better off you'll be to get that good seed soil contact, especially into heavy rye biomass. That's going to be a really important factor. And lastly, I think as we think about moving where our nitrogen fertilizer applications are at, we may have it. If you like to split apply your nitrogen or go in season, maybe think about moving that up a little bit, especially in years where you have a lot of cover crop biomass. Can you move to a pre-plant application or a split application? That may help make some of that nitrogen a little more available, try to overcome maybe some of those immobilization effects of the cover crop. And so we've started a lot more on-farm work with this to see if we're also seeing this in farmer fields. I believe this nitrogen effect is ultimately true. I think that, but I don't think we always have to be losing yield in these systems. And as we just get better and better at management and better at keeping these the cover crop biomass low, then I think that we're going to be in really, really great shape. So with that, I'm happy to stop for a few minutes. If there's any questions, I'd be happy to answer them before we turn it over to Eric, who's gonna scale up this cover crop to field level and quantify field level nitrogen losses.
Great, thanks, Matt. Yes, we do have quite a few questions for you, so we'll try to rifle through a couple of them here. First question, did you incorporate the cover crop or just kill it?
Right, in this case, we just killed it. So we're operating in a no-till system. So we just sprayed it out. We did not incorporate.
Okay, great. And then the table 3 NRECs, are they for only no-till systems?
So I would say, so our estimation is no, the cover crop does get taken up. I don't think some tillage may stimulate some of that decomposition, but ultimately that cover crop is likely to get tied up in that biomass. So I guess we don't have any other things to compare it to, but generally speaking, when people are using cover crops here, they're using it in no-till systems. So in this case, we wouldn't probably recommend the need for tillage in this operation.
All right, so then let's see. Does the fact that both the corn and the cover crops are grasses play into N usage?
This is a fact. So there is this potential, right? I can't speak too much on this, but right, we talk about this potential allelopathic effect of that grass cover, those grass cover crops on the corn production itself. Generally speaking, the rule of thumb is that 10 to 14 days to reduce or eliminate that effect, and we feel that's generally been true. A lot of other studies in the Midwest with cover cropping have shown that you don't have to have that yield reduction as long as you follow those guidelines.
All right. Did you measure the N content of the cover crop, or could there be a confounding factor where cover crops grow better under the same warmer water conditions that also leach nitrogen?
So, yep, we always measure the amount of cover crop biomass, and obviously we always and we also looked at the carbon to nitrogen ratio, and generally the larger biomass was reduced or made that carbon to nitrogen ratio greater. So larger biomass, the effect of the larger biomass might actually be confounded with that larger seed-N ratio, which could cause more of an immobilization effect in season, that nitrogen tie-up. Right now, we're fairly, based on our results and some other trials, we've really tied that nitrogen effect to just simply nitrogen uptake. That nitrogen just isn't there, rather than that cover crop causing a lot of immobilization issues also into the season. But I didn't quite address. What was the other part, Amber, with the confounding with the cover crop group better?
Let's see, where'd that question go? Or it could it be confounding that cover crops just grow better under the same warmer water conditions that also leach nitrogen?
So the weather conditions is tricky, right? So the weather patterns obviously are going to be the ones that drive the amount of nitrate leaching. I think in our experience, it's really been how warm the fall is that drives the cover crop growth. So those years when we had above 2,000 pounds, it was because we had most of that growth, or a lot of growth, occur in that fall period. But I think the overall point is actually kind of interesting, right? Because in fall conditions, when there's a lot of rainfall event, the cover crops are going to grow better, but they're also going to take up more of the nitrogen, potentially having an even bigger positive effect on water quality.
Awesome. Well, there's some other really great questions in the chat, Matt. So if you would be able to type in answers as you're able here through this next section, because I want to get Eric started. And everybody, thank you so much for your great questions. This is awesome. Really appreciate your time and attention this morning. Make sure when you have a question that you're putting that right in the Q&A box, which is different than the traditional chat box. In this webinar feature of Zoom, we're able to have this Q&A box. It allows you to be able to vote for other people's questions that you might also have. It allows people to type answers back to you, and it's just easier to not lose questions. So if you did put a question in the chat box, please go ahead and transfer it to the Q&A box, and we'll do our best to get those answered for you. So, all right, we're going to go ahead and transition to the second Wisconsin speaker. Our next speaker is Eric Cooley. He is the Wisconsin Discovery Farms Director. So go ahead, Eric.
Great, thanks, Amber. And as we get started here, I would really like to first off recognize both Aaron Wunderlin and Ryan Heiderman, who really put a lot of the did a lot of the data analysis, trend analysis, and put the data slides together that we're going to be looking at today. So to go back to something that Amber talked about early on that I just kind of wanted to reiterate is that, the Discovery Farms programs in all states, and especially is in Wisconsin, is truly a farmer-led water quality and research and education program. And again, Amber talked a little bit about our steering committee, but we've got 18 members of different agricultural and environmental groups. And then we also have some advisors from a lot of the state and federal agencies that we have here in Wisconsin. And really what we use this steering committee for is to identify kind of the current and emerging research water quality needs of the agricultural industry. We also use members of the steering committee and their associated groups to help us identify great participants to take part in this type of research. And then finally, and probably most importantly, is we really use, again, the groups associated with our steering committee to help us get out the research. We collaborate with them on some educational and outreach events. So we really use our farmers in all aspects of the research that we do in Wisconsin. Give you a little bit of kind of history of how we've shifted gears over the years in Wisconsin. Again, Amber talked about how our program got started back in 2000. Really initially the research need was animal manured systems. And in Wisconsin, we really do have a lot of dairy, so that was one of the major focuses. So we looked at both dairy from a confinement operation as well as some grazing dairies, as well as how do these dairies sit in different landscapes that we have throughout Wisconsin, and really what is the timing and the magnitude of water, soil, and nutrients that are being lost from these different systems, as well as landscapes throughout the state. And then we also address some other needs, such as the headland stacking of poultry manure and any potential water quality impacts of that. And then apart from water quality, we had done some other kind of special projects, like some depth to bedrock determination in shallow bedrock areas in Wisconsin, and some feed storage runoff from different feed storage systems for dairies throughout Wisconsin. Now, if you look at that map on the right, and I'm not sure if my pointer is going to show up here, but you see this kind of horseshoe that was really developed in those first 15 years. And that was really based predominantly on where we had staffing to do this type of research. So I'm up in the Green Bay area. So we had staffing there. We had staffing down in the Madison area. And then we also, in our main office in Pigeon Falls in Western Wisconsin, we had staffing. That really is what drove our capacity to do research, rather than having a couple-hour trip to the middle or north of the state to try to do some of these projects. So now in recent years, we've looked at, again, some different areas of the states like I had talked about, but we're looking at some more diverse types of cropping, such as cash grain and some vegetable crops. As Matt had talked a little bit about, is we've done some nitrogen use efficiency work in corn production. And then we've actually started some new work with actually nitrate leaching below crop root zone. And really, what is that going to look like from a water flux and a nitrate leaching concentration below that crop root zone. And then finally, one of the things that we really modeled after the Minnesota Discovery Farms program is we really made a shift in the fall of 2018, where it wasn't Discovery Farms or U.S. Geological Survey staff collecting these samples. We were working with a local partner that we would train to aid us in the sample collection and maintenance of the water quality data that we were collecting. And this really provides so many more benefits. Again, we can now service the entire state of Wisconsin, apart from where Discovery Farms has staff or USGS. And, we're really seeing, especially in these first couple of years, just the collaboration of those local partners with outreach. It just is a much better model than we had previously used. And I'm sure, with any of our efforts moving forward, that we are going to be using partners to do that type of research from this point forwards, because we really see just multiple benefits of working with local partners really to aid us in doing this research. So now getting into some of the water quality, to build off a little bit about what Matt talked earlier, kind of at the plot scale. And the main one that we can pull from is a paired study that we had down in Rock County, which is in southern Wisconsin, where we had a paired basin study where we had done a cover crop trial. And this was a 6-year study. And these are the two basins, basin one on the left. And you can see, even though we had quite a bit more slope in this basin, our basin 5, you'll see in the water quality results here, we actually had, because we believe the soil types are a little bit different, we actually had more consistent runoff from site 5 than we did site 1. But the great thing was, when we first selected these sites, is that they were very similar in size, 9.4 acres for site 1 and 9.7 for site 5. They both had south-facing aspects, which is a very important thing when you have the snow like we have in Wisconsin. So we were excited to really get basins that we thought were going to be pretty similar with respect to runoff. Some of the dynamics of the study is we had a corn, soybean, corn rotation, and these were matched in both the 3-year treatment as well as the 3-year experiment portions of this study. The corn was strip tilled and soybeans were no tilled. This farm has used precision agriculture for many years, and they've really seen kind of a real common application of the fertilizers that they put on this. So nutrient applications between the two basins were actually quite consistent throughout the years. And These were non-manured systems, so it was all commercial fertilizer. And then in our treatment portion of the study, we had rye, a winter rye cover crop that was planted in that basin 5 for the last 3 years of the study. And I also did want to thank the USDA NRCS for funding this funding this study through the 201, 202 standards. So now getting into the data. So this graph, we've got precipitation on the top. And we can see that those first 3 years are what we're calling our baseline. And the second 3 years are our experiment, which we just finished up this last year. And the precipitation patterns really for the first 5 years of the study were over what we would expect from our 30-year average, which is about 37 inches per year. So our average is right up around in here. And we can see that in those first 5 years, we had above average precipitation in all 5 of those years. Whereas this last year, we were really dry and were significantly below that 30-year average. Corresponding runoff trends, we can see here that in all years, again, that RE5 basin, even though it was a little bit less sloped, we think because of the soil type that we had consistently more runoff in all years that we did monitor that basin. But we can also see that in these last 2 years, we've had less runoff than previous years. And in field year 21, we basically had no runoff from either site because it was so dry. So the first year the first way that we really tried to look at the data of how can we really tease out the effect that the cover crops might have is that we grouped all of the data for that 3-year time period between when the cover crop was planted and when it was terminated. And in those years where we didn't have cover crops, it was really from the time that the crop was harvested until the time that that crop was planted the next year. And that really did correspond quite well with the cover crop treatment because it was planted very soon after crops were harvested when it was planted. And then again, it was terminated just prior to or slightly after that crop was planted the next year. So those time frames really do correlate between the 2 time periods. And we can see water up in the upper left-hand corner in our baseline period. Again, we had more runoff in that RE5 basin. And we also had that in the experimental period as well, although to maybe a little bit lesser degree. We can see that we had almost double the amount of soil loss or over double the amount of soil loss in that baseline period. Whereas in the experimental period, again, only when those cover crops were active, we can see that they were very similar over those 2-3-year periods. Total phosphorus, our values were again almost double between the 2 basins, whereas when we got into the treatment period, we saw those 2 even out. And then finally, we had for nitrogen, total nitrogen, we had slightly greater total nitrogen loss in that basin 5, but once the cover crop was planted, we actually saw a decreased amount of total nitrogen that was lost again when those cover crops were active. So this was one way that we really tried to take a look and assess the effectiveness of cover crops and really focused in on that time period where those cover crops would likely have a benefit, again, from the time that they were established to the time that they were terminated. So then to dive into the data a little bit more, again, being cognizant of the fact that RE5, the site 5, had more runoff events and it just ran off more often, is we really kind of separated these out and only looked at the matched events that occurred between the 2 sites. So basically having a runoff event at both site 1 as well as site 5. And what we did is we graphed the site 1 on the x-axis and site 5 on the y-axis. When we look at runoff itself, although we didn't have a real strong statistical correlation, one of the things that we did notice a little bit in the data is, especially for some of the smaller events, we were actually having more runoff in the cover cropped basin, which is the experiment, which was the bold, the filled in dots and the darker lines, we actually saw a little bit more runoff from the cover crop site as compared to the non-cover crop site. And this may go along, and we're diving into this a little bit more with some of the specific events, but this may go along with other research that shows as you have that cover crop growth in the field, especially in Wisconsin environments where you have the snow, you might get some additional depth of snow that's accumulating and resulting in additional runoff because of that snow accumulation. So that may be one of the explanations of why we saw slightly higher or greater runoff in the cover crop basin versus a non-cover cropped. But now moving on to soil in the upper right, we had a very strong correlation of those matched events that really shows that that cover crop did significantly decrease the amount of soil that was lost where we had cover crops as compared to where we didn't. Similar trends for phosphorus. Again, we had a very strong correlation where we saw the phosphorus decrease in the cover crop basin versus the non-cover cropped. And finally, although not quite as statistically significant as soil or phosphorus, we did still see from that surface water perspective a decrease in the total nitrogen that was lost in the cover crop basin as compared to the non-cover crop basin. So again, all surface water data, and we saw pretty statistically significant data where we matched these events with soil, phosphorus, and nitrogen decreases in that cover crop basin. So finally, one of the other pieces that we're really looking at that goes a lot to what Matt just talked about is the tie up of that nitrogen in the soil profile from those cover crops. So I just really wanted to briefly connect on one little data slide that we got from a tile monitoring project that we did over a 3-year period from 2018 to 2020, where we had 4 intensive sites where we continuously monitored flow and water quality, 9 intermediate sites where we continuously monitored flow and did a biweekly grab sample, and then 11 basic sites where we did a biweekly instantaneous flow measurement as well as a grab sample. And I will say at all 24 of these sites, we collected a biweekly grab sample if there was flow present, and that's the data that this next slide is going to represent. So when we went through the data, we noticed some trends where we saw, at least in the cover crop fields, where we actually saw nitrogen concentrations decreasing in many of those plots compared to more straight line data that we were seeing in the non-cover crop fields. So the best way that we could find to represent this is really looking at that soil nitrate concentration on an individual site basis. We did a comparison of how did that fall nitrate concentration in November, or if we didn't have a November data point, we went back to October. How did that change through the wintertime in the tile drainage water that we saw in cover crop versus no cover crop fields? And what this data is actually showing us is that in those no cover crop fields, which are the brown lines, we can see that those nitrate concentrations are relatively stable throughout the winter in Wisconsin, and we don't see a large variability, and those concentrations really remain quite consistent until we get into that April time period where we see them slightly increasing again. Whereas in the cover crop plots, we do see those concentrations actually decreasing in concentration as we go throughout the winter, and again, much like the non-cover crop fields, start rising as we get into that snow melt in spring and when we get water moving through that soil profile again. So again, I think this data is really great as it validates quite a bit of what Matt was saying in his data from a water quality perspective. And you know, we are still doing a lot of more statistics and work on really trying to tease out more information out of some of this, as well as the cover crop trial And we will have some publications coming out on this probably in the next 4 or 5 months. So with that, I'd be happy to answer any questions that came in.
Yeah, Eric, great, thanks, great job. One of the questions that came in was about, were you able to evaluate soil physical properties such as soil water infiltration or bulk density? Wondering if that might also help explain some of the observed differences in runoff in the surface water study with covers.
Great question. Yeah, so going back to the surface water study, we did not do any bulk density testing or infiltration tests at this site. We actually did with some of the tile sites where we looked at a number of different soil health metrics and did not find a correlation in that site. But this site specifically, we did not do that. It just is, we had slightly different soil types that whether there was a restricting layer down below or just the soil properties themselves, it just happened. And this is actually a picture of the cover crop in site 5. But yeah, for whatever reason, it just ran off more, but we did not do those measurements.
All right, another question. This one is about, I'm gonna do this tile one next, I think. Are those winter tile nitrate concentration data from base flow or event flows?
Great question. So it could be either. And during the winter time period in Wisconsin, we do have more common base flow periods unless we get a really good melt event that pushes that entire frost profile out of the soil. So based on our sampling scheme, we could be testing, it was a biweekly sample, so that may have occurred during base flow time periods, or it could be occurring during storm flow. And it really is, it's really a guess whether that happened. But surprisingly, in the data, we saw relatively consistent soil nitrate concentrations that were not in the tile, that were not strongly driven by storm flow or base flow. There was to some degree, especially in the springtime, where we had a lot of flow, but it wasn't as strongly as impacted as we saw with some of the other soil nutrients.
All right. Did increases in runoff lead to increases in nutrient transport despite lower nutrient concentrations?
Can you read that one more time? I did.
So I think what he's asking about is, having more runoff. Did that lead to greater total loss, even though the concentration was lower? And I assume he means on the cover cropped sites.
So yeah, and that is one of the things that, again, going back to the data, it ran off more, and we correspondingly in both the data that I'm showing here, which is really in that cover crop time period, which is throughout most of late fall through early spring, we consistently saw greater loss in basin 5 as compared to basin 1 because of the extended runoff. So again, looking at some of the concentration information, they were more similar with concentration, but the volume of water in site 5 really was one of the major factors in driving those events, and not a concentration difference. I think that's what the question was asking.
I think so. And, perhaps if we didn't quite get your question answered, Mark, go ahead and rephrase it in that Q&A box and Eric can type in an answer. Mm-hmm. One last question here, but you'll have a couple to answer in the chat here, Eric. Okay. One last question about analyzing frozen or non-frozen precipitation. Sounds like this person knows that there was a rain event on snowpack in those areas during the monitoring time period. Can you just talk a little bit about how you have used the knowledge of whether it was rain or frozen precipitation, and how we use information about whether the ground was frozen or not as we were doing analysis.
Yeah, great question. So we, at each of our monitoring sites that we have within a region in a state, not always on every farm, but at least within a localized area where we may have multiple sites, we do have temperature probes inserted in the soil at a number of different depths, 2, 5, 10, 20, 40, and sometimes 80 centimeters in the soil. And what we do is we call the soil frozen if the temperature is below freezing at any depth in that soil, because what we see in Wisconsin is a lot of times we can have the surface of the soil actually be thawed as we're getting into spring and snow melt, but we might have frost still in that bottom portion or lower in the soil profile that will not allow water to percolate through that soil past that frozen layer. So we have broken the data apart into frozen versus non-frozen conditions, and again, are really trying to look at some of the intricacies in the data. We are in the process, especially with the study that I have right now. We just got our data the end of last year and are doing a lot of the analysis right now to look at some more of the intricacies of how does frozen play, and then really, to go on frozen versus non-frozen when the cover crop is established. Really, is there any lingering effects from soil antecedent soil moisture concentrations or contents, I should say? How does that play maybe even a little bit after? As we stopped at the termination date, but was there still some effect that might be corresponding into even after that termination date? So those are all things that we will be looking further into this data set with, and will hopefully be part of that report coming out here in the next few months.
All right, awesome. Thanks, Eric. Thanks, Matt. Great representation of our Wisconsin program here. Eric, you do have a couple more questions in the Q&A to answer here after we move on. And thanks everybody for using that Q&A to ask questions and vote for questions that other people that you might resonate with. It's really, and also make sure you read the answered ones. Some really great additional information from our speakers. So, all right, we're going to move to the west just a little bit now. And our next session is from the Discovery Farms Minnesota program. We're going to hear from Tim Raditz, and Tim works as the Discovery Farms Minnesota coordinator. So go ahead, Tim.
All right, can you hear and see everything I got up there?
Looks good.
All right, great. Well, it's great to be here with you this morning. I'm going to talk a little bit about our Discovery Farms program, a little bit about our setup with what we got going for ag and landscapes in Minnesota, since we might have quite a few out-of-state people. And then we have a couple of studies started looking at the effects of cover crops on surface water runoff and tile drainage. So I'm going to set those up at the end to show what we have going. We don't have a whole lot of answers yet, but we are collecting some data on these very challenging issues. All right. So as Eric and Amber talked about before, we're set up the same way in Minnesota. We essentially copied what they were doing in Wisconsin and set up a similar program in Minnesota, focusing on farmer leadership. That's huge for us. And then credible research and communicating those results. We do focus on edge of field surface runoff and tile drainage data on privately owned farms. And we set up automated equipment that gives us a really high quality data set that we can use for our education program. Our program really is built on partnerships. Farmers are extremely key in these partnerships. One is we're organized by the Minnesota Ag Water Resource Center, which is a nonprofit organization in Minnesota comprised of many ag groups throughout Minnesota. And the mission of this nonprofit is to assist farmers with water issues in the state. And so Discovery Farms is a program that is organized through that nonprofit. We also have a steering committee where a number of farmers sit on and really help us determine projects and look at where our data needs are and what we really need to be looking at, and also really lean on our farmer participants in terms of when we're out working with them, what are they doing, how do they react to certain conditions, just getting a know of what's going on locally at their site. We partner with the Minnesota Department of Agriculture to collect our water quality data set. They do an excellent job at installing equipment and providing us with that high quality data set that we can then use in our education and outreach. And lastly, Eric touched a little bit on this in his presentation, but wherever we have locations, Minnesota is a big state and we don't have the staff to run all over the state to collect samples and work with our sites on a daily basis. So we partner with local SWCDs, which are soil and water conservation districts or watershed districts. And they're actually the folks going out and making these sites work, collecting samples, shipping them off to the lab, helping us with education outreach events, just all sorts of beneficial things for our program that these local partners provide. So if we look at, we're supposed to cover a little bit on water issues. So Minnesota's the state of 10,000 or what is it? 10,000 lakes we have on our license plates. So water is very important to the people in Minnesota, and we take a lot of pride in our water and the water resources that we have in the state. So there is a lot of concern over agricultural practices, primarily because ag's such a high land use in Minnesota. Just a large percentage of Minnesota's land use is in agriculture. So there's a lot of interest in knowing how our ag practices are contributing to water quality in terms of whether that would be through surface runoff or agricultural tile drainage, the pipes that are installed subsurfacely and remove a portion of that soil water. So it is a hot topic and a big issue in our state. Where we are now, we have 3 current farms that are operating. We've monitored at a bunch of different locations throughout our program time period. We've been going since about 2010 or 2009, we've been collecting data. And so Minnesota is a very diverse state in terms of landscapes and also ag operations. If we start in the southeast, that, excuse me, is part of the driftless region. So we have quite a bit of higher slopes in this area and less soils where erosion concerns are pretty significant. If we move into south central Minnesota, this is where primarily our tile drain landscape is, where we're growing a lot of corn and soybeans. And then what's interesting about Minnesota is we have a lot of ag that it moves up into the extreme northwest corner, where actually the water flows to Canada and through the Red River Basin into Lake Winnipeg. So that brings a whole additional set of challenges and issues that we have to work on. In terms of ag operations and enterprises, we grow a lot of corn and soybeans, and we have a lot of tile drainage. So that's primarily what our data set is focused on. But we also grow a number of sugar beets and vegetable crops, whether it be canning for sweet corn and peas. In terms of livestock, we have a number of turkeys, a number of hog operations, and some dairy as well. Not quite the amount of dairy that Wisconsin has, but we do have quite a bit of dairy going on in the state as well. When we think about cover crops and challenges, we do have significant challenges in terms of establishing cover crop in our traditional corn and soybean areas. I was listening to a presentation yesterday and by a researcher who's tried to establish a lot of cover crops, and he has had success in establishing cover crops in the corn soybean rotation about 1 every 4 years. So not a very high percentage of getting a real robust cover crop. There's just a limited growing season, and by the time we can get it going, it's really, really hard to get a robust crop that's going to be available for the next spring in those situations. However, we do have a lot of opportunities where cover crops are taking off and they're being used. I think the dairy forage rotation, where we have a lot of corn silage, is really a good place to incorporate cover crops, and has been a good place for a lot of farmers to incorporate cover crops. But also the vegetable and canning crops and sugar beets provide some opportunities for a longer fall period to establish the cover crop and get those cover crops going. So while there are some challenges, there's also definitely a lot of opportunities to incorporate cover crops into agriculture in Minnesota. So I was just going to give a kind of a rundown of the data we've collected over the last 10 years and sort of where we're at and what we're really looking at. This would be the amount of surface runoff or tile drainage that we're collecting on an annual basis. We typically see a little bit more surface runoff or a little bit more tile drainage than surface runoff on average. And most of our surface runoff, or most of our tile drainage, happens during the growing season. So Eric was talking a little bit about the flow during the winter months that they see in Wisconsin. We typically don't see that much flow during the winter months from the work that we've done. However, when we look at surface runoff, about half of our surface runoff occurs during that frozen soil time period, during that snowmelt time period. So that is really important for our climate, you know, really to get a good handle on that snowmelt, and really has some interesting impacts on the type of best management practices that we can use to really look at slowing phosphorus loss or nitrogen loss or sediment loss. If we look at the timing, I touched a little bit about this in the last slide, but 82% of our surface runoff occurs from March to July. So that's our active time frame. And then almost 70% of the tile drainage occurs from March through July from what we've monitored. So that March through July time period is extremely active in terms of our surface water runoff and tile flow. When we're looking at soil loss, we look at total suspended solids is what we monitor for. And we did some work to look at the mineral fraction versus the organic fraction of that total suspended solids. It's primarily the mineral fraction, meaning it's mostly soil particles. But when we see soil loss, we typically are focused on our surface runoff sites. We just see a lot more soil loss coming through surface runoff than through our subsurface tile. Even our tile sites that have open intakes, we see some higher results there, but they don't even approach the surface runoff data that we have in terms of magnitude. Timing of soil loss is also really interesting. May and June for Minnesota is just critical. If you don't have cover during that time, you can be at risk for higher soil losses. So these are where cover crops can come into play. If we can get something going and not kill and till, but have some sort of protection in May and June as our primary crop is establishing, we can really have some benefits and really reduce our soil losses. Phosphorus is another concern that we're looking at in Minnesota, and similar to soil loss, we're looking at focusing more on surface runoff than tile. We just don't see a whole lot of phosphorus movement through our tiles in the work that we've done in Minnesota. Nitrogen is where the story flips a little bit. We do have significant nitrogen concerns in Minnesota, but if we're focusing on nitrogen, we're going to be focusing on that subsurface tile rather than the surface water runoff. That's just where we see most of our nitrate or nitrogen move through in Minnesota. So if we look at combined contributions, so these are sites where we have both surface water runoff and tile drainage in the same spot. And we're looking at the amount of runoff. We typically see about, on average, 73% of our flow go through the tile on any given year, compared to about 27% of the surface flow in any given year. So we see on a field that has both surface drainage and tile flow, about 3/4 of the water that's going to leave that field goes through the tile, and about 1/4 leaves as surface runoff. If we look at soil loss or TSS yield, overwhelmingly 96% of that soil loss is through surface runoff. So that's really where we want to focus. Phosphorus yield, a similar story there. Total phosphorus above or about 85%, and dissolved phosphorus as well, approaching that 80% moving through surface runoff compared to tile. So soil loss and phosphorus, we're really focusing on surface runoff. And nitrogen, we're really focused on subsurface tile, where we have 95% of our nitrate that's lost from this fields moving through the tile, and 85% of our total, or 84% of our total nitrogen. So just in summary, surface runoff concerns, primarily soil loss and phosphorus loss. Tile drainage concerns, primarily nitrogen loss. So when we're looking at assessing the role of cover crops, we have a couple continuing studies that we're really trying to focus in on, and one would be in our Redwood County site. And this is a paired basin design setup where we have north and south basins. The blue basin would be the north basin, and the green basin would be the south basin. Both of these are managed the exact same, or have been, from 2017 through 2020. It's a corn soybean farm, no manure. They no-till their beans. They spring vertical till their corn, use fall anhydrous for a nitrogen source, and they fly on cover crops in August to try to get some established of cover crop in the corn and soybean years. Starting in 2021, cover crops were flown on just the north site, but not the south site. All other management variables continued. So we're just looking at that one difference, trying to determine impacts to water quality in terms of surface runoff and also tile drainage. 2021, we were able, or the fall of 20, we were able to get a really good establishment of cover crop. This would be a winter rye. And this is what a good establishment looks like in a flown on cover crop in a standing cornfield. So at the end of November, we have pretty good growth, and the following spring that really came back nice and green. It's unfortunate because 2021, so the fall of 2020 moves into 2021, we do have water data. However, we had such a drought in 2021. Although we had such a good cover crop, there just wasn't much surface runoff or tile flow to really try to establish if there's any water quality improvements due to that cover crop. But if we're looking at just the pairing of the basins from 2017 through 2020, we really have a good pair of the north and south basins, where we have a really good relationship for monthly flow, TSS yield. You know, the north basin tends to have higher TSS yield than the south basin. TP yield, we have a pretty good one-to-one relationship between the two. And then nitrogen yield, or nitrate yield, the south basin tends to have higher losses than the north basin. So these are all comparisons when nothing was changed in terms of ag practices between the two basins. So our question moving forward is, can we shift this relationship between the north and south basins with cover crops? So if we do this work for a few more years after the change and we get the same sort of relationship, we determine no difference, we can determine an improvement or decline based on the change in practices. So unfortunately, we don't have much data from 2021 because of the drought and the low precipitation amounts. But as we're continuing on with the study, and we should have some really good information going into the future. Another site where we have where we're assessing the role of cover crops is a site in Wright County. This farm was a dairy farm, had dairy forage rotation of corn and alfalfa, heavy tillage. Dairy manure was used as the primary nutrient source. So our first 3 years there was corn silage. There was a year where they planted peas, triticale, and alfalfa, and installed some newer tile there, and then grew some alfalfa. Well, at the end of 2019, they moved on from dairy farming, or no longer milking cows. So they switched up their farming practices in that field as well, and are moving to more of a soil health limited tillage rotation, where we're going to grow soybean, wheat, and corn with covers, limited tillage, and use some bedding pack because there won't be any liquid dairy manure anymore as the primary nutrient source. And what's interesting, we have a long-term record of water quality data information here, both surface runoff and tile flow. This chart just shows the nitrate concentrations in the tile, and we can see an increasing trend in those corn years and the effect of that alfalfa, and really pulling down those nitrate concentrations, and that's really a benefit of that alfalfa crop. So as we go into the future, it'll be interesting to see if we can prevent that rise of nitrate concentrations with our different crop rotation of the corn, wheat, and corn, or soybean, wheat, and corn with covers, or if we still see some higher nitrate levels in the tile, even with the change in farming practices. So with that, that's all I have for you today. If we have any questions, I'll be happy to take them.
Yeah, so Tim, there is one in the chat already. Is the phosphorus transport via surface versus tile the same for manure or commercial sources of nutrients?
Yes, I would say that is correct. Where we tend to see higher phosphorus movement or transport in the surface and tile is where we see higher soil test phosphorus fields. And so I don't think it depends on the nutrient source, whether it be commercial or manure, but typically manure sites are places where we can get some higher soil test phosphorus levels and where we can see some more dissolved phosphorus movement through surface and tile.
Awesome. One more question. What covers did they plan in the new soy, wheat, corn rotation?
Right, great question. In the soybean and corn years, it's pretty limited to winter rye, just because that is what grows. It's a very tough crop. But in that wheat year, since wheat is harvested earlier in the year, they will plant a cover crop cocktail of some form of some legumes and some brassicas and some grass.
Nice. Just as a summary, Tim, from Minnesota and Wisconsin, because you do some work in Wisconsin too, what would you say are the big questions that we have about covers and their impact on nutrient losses, and what do you see as the opportunities?
Well, I think the opportunity is, I think, in our climate, in that dairy forage rotation, or if we're growing wheat or canning crops, something where we're going to have more of a time frame to get that cover crop established. I think there's great potential for benefit in terms of reducing nitrate movement to tile lines. I think we have more of a question on phosphorus and their impact on phosphorus losses, specifically dissolved phosphorus losses. We tend to see most of our dissolved phosphorus losses during winter runoff. And there has been some work throughout Canada and in more climates similar to ours, where they have observed some more dissolved phosphorus release during winter time of some of our cover crops that go throughout the winter. So that's, I think, a big question we're looking to answer is, in our climate where we can get good cover crop establishment, is that going to improve our dissolved phosphorus situation in the wintertime runoff, or will that create a few more challenges? And how do we manage that?
Yeah. All right. So a couple other great questions came in. This one is, are you going to look at bioaccumulation for cover crop species? So for example, what species are more efficient and effective at mining nutrients from deeper depths to the surface for the cash crop to grab and recycle the nutrient? How dense are some of these species for nutrients? So you know, kind of a general question about the different roles that cover crops might play. Is it safe to say that that's a good future research piece or something to try to keep an eye on? What would you say about that?
Yeah, I would keep an eye on it. I think it is a great question. I think in terms of how we're set up as a Discovery Farms program, we work in the real world and with real farmers. We don't have a whole lot of control at practices going on the landscape. If something happens and the farmers are still farming these fields to continue their livelihood, I think a question like that is more appropriate for our research facilities and our extension personnel like Matt. And we have a lot of good extension personnel in Minnesota that could look at some of these questions and really nail down some of those more specific questions about cover crops.
Collaboration is key, right?
Yeah, we can't do everything.
Yep. All right, another good one about surface versus tile phosphorus transport. Is the transport of dissolved phosphorus mostly on the surface instead of tile, just like total phosphorus?
Yeah, I think I showed this. So this is sort of a graph that can explain some of this. But in this chart down here, we're actually looking at, so these are summarizing our sites where we have surface runoff and tile drainage in the same spot. So we're monitoring them on the same fields and same drainage areas. And even for dissolved phosphorus, we see almost 80% of that come through surface runoff rather than subsurface tile. So that surface runoff is a primary driver of dissolved phosphorus loss as well.
Great. And then one more here. The map shows many retired farms and relatively few current sites. Is that due to funding or volunteer growers or some other factor?
Well, I think it's due to a number of factors, not due to volunteers. We have we have an application process to enter the Discovery Farms program, and we have a stack of applicants waiting to join into the Discovery Farms program. I think our challenge has been more on the finding the right project and finding the right funding source to continue to build out our data set. And we started off by just setting up monitoring sites across the state to get some data, and we've developed that base data set. We're looking into more specialized projects now too, looking at more paired basin studies to assess specific concerns and questions.
Yeah, and that was a similar question that was asked in the chat, and I answered it with the additional information of we limit our time on a specific farm, at least in Wisconsin. We purposely limit that to 7 years just because it allows us to get a good variety of weather events. It gives us, at least one full crop rotation if it's like an alfalfa rotation or a longer rotation, and also allows us to continue to move equipment around and have new participants, new partners. That's kind of like 7 years becomes a good spot to have a good time to learn what's going on in that spot, learn something new, have a good understanding, have a great relationship with the partner, and then also move on before anything gets stale.
Yeah, I think that's a great point. As researchers, the longer the better, right? If we had 50 years of data, we'd be way better off than if we just have 7. But we have to balance out those other factors that you just talked about there.
Yeah. One more question came in here quick, Tim, about the cover crop study. Was the cover crop killed off with an herbicide in 2021 or planted through to keep cover on the ground during the early growing season?
That one, I believe, was planted through and then killed with a herbicide.
Nice. All right. Well, thanks, Tim. Great information. That allows us to move on here with actually a couple extra minutes for our Arkansas partners, which we know that Mike can always use up a couple extra minutes, right, Mike? He's still not responding to me yet. Okay, so as Mike gets his screen ready to go, I'll go ahead and introduce them. Our next session will be from the Discovery Farms Arkansas program. And today we have Dr. Mike Daniels and Dr. Bill Robertson with us. Mike is a soil and water conservation specialist for the University of Arkansas System Division of Agriculture's Cooperative Extension Service. And Dr. Bill Robertson is the cotton extension agronomist with the University of Arkansas System Division of Agriculture Cooperative Extension Service. So Mike, go ahead, and we'll excited to learn what's going on in Arkansas.
Can you see my screen okay?
It looks like it's not in presentation mode yet, Mike.
It's not. Hold on
Yep.
a second. I'll get it there. Too many buttons to push. There we go. Is that better?
Yep, that looks better.
Okay. Yeah, my name is Mike Daniels, and thank you for the introduction. And Amber, you know me well. The extra time could come in handy for a long-winded guy like myself. I did want to talk today. We're going to talk about our Discovery Farm experiences with cover crops. And I've invited Dr. Bill Robertson along. We're going to do something a little different than the first two talks, in that our agriculture is different. We face some of the same issues, quite honestly. Drainage is an issue for us, but we do not do any tile drainage because of our soils. I'll talk a little bit more about that in a minute. All of our drainage is done by land leveling and shaping the surface to get surface runoff, because we have some very heavy textured soils that are easily compactable, and we don't get the downward movement. But some of this work is going to show you some progress we're making towards opening up the soil profile with cover crops. First, I want to talk a little bit about our Discovery Farm program. These are some of our sponsors and partners. We have just been blessed. We don't have a budget coming from the state or anything. We just simply live from grant to grant. And so we go out and work hard, but this program has been something that a lot of people in Arkansas and around the country are interested in. And so we have a very diverse, both public and private. I want to give a shout out though to the state of Arkansas NRCS. They are, because of the things, the activities, conservation activity 201 and 202 in our state, which is cost sharing for edge of field monitoring. They have been a huge funding partner and technical assistance partner in our program. So we have a partnership called the Arkansas Conservation Partnership, and they've played a big role. We got started by coming up to Wisconsin and Minnesota. We took Farm Bureau members up there to see the Discovery Farm program, and then we came back and modeled it back on there. But our farms are not as integrated as the farms in Wisconsin, Minnesota. We're either row crops or we're either livestock. Don't tend to be both. This is just a shot of some of our, we have retired some farms, but this is what we have active right now. And if you kind of divide the state down the middle, the western and northwestern part of the state, you can kind of see by this topographical representation of the state. Up where we have our Ozark Mountains, Ouachita Mountains, we're primarily livestock operations, poultry, beef. We do have one grazing dairy we're working on, but our dairy industry is really not very big anymore. But in the eastern part, we're part of the Mississippi Delta, and you can see that over here, we don't have much relief, and this is our grain area. We grow a lot of rice, soybeans. We produce over 50% of the rice grown in the state, in the United States here in Arkansas. But our primary row crops are rice, corn, soybean, and cotton. And we have 4 farms that we have looked at cover crops, and primarily we're going to be presenting the one down in southeastern Arkansas on the corn and cotton. What are some of our conservation issues in Arkansas? Well, maybe the number one is not water quality as much as it is water quantity. Our groundwater withdrawal for irrigation is huge. We're dependent on groundwater for irrigation. We're seeing some conversion to surface water. This picture at the bottom here is actually a irrigation district that takes surface water out of the Arkansas River and then pumps it down irrigation canals. But we are a state that has to irrigate to remove any of the uncertainty in crop production, because we can go long periods of very little rainfall, especially in the summer months. And so we're pretty much dependent on irrigation. And so therefore, when we do monitoring on our row crop fields, we not only monitor precipitation events, we also have to monitor irrigation events. And because we will get some runoff from irrigation, but not nearly as much as we get from rainfall. But we get that a lot of that rainfall in the winter months and stuff. Soil erosion, soil quality, and really what we're terming now is soil health. We're looking at that on a lot of different sites, but we've included that as part of our discovery farms. We're also looking at obviously nutrients and runoff. But we're also starting to looking at some of these nutrients and runoff and trying to determine if the practices we're using are profitable. And we found some neat things with that. And then we also are trying to help cotton farmers through Bill Robertson's effort to document to the supply chain the sustainable efforts they're using in all these areas. And he'll talk a little more about that. Why do we need the program? We felt like we've got a lot of water resource concerns we need to address. We felt like Discovery Farms was the way to do it. We can measure progress. We can evaluate conservation practice. We can develop the solutions. But the thing that attracted me first to the Discovery Farm program and why we wanted it in Arkansas is it involves the agricultural producers in the solution process. Who knows their capabilities and their farms better than anybody else? It's the farmers. And I think when a lot of regulatory agencies were trying to get a handle on how to deal with agricultural runoff, they didn't always include farmers in that solution process. So we think that's a very important part of the program. This is just some pictures of some of our different sites using the ISCO samplers. We use a lot of trapezoidal flumes. They're designed to have plant trash and debris to go on through and not get stuck in the flumes. We also have to monitor irrigation water because that's one of our hydrological inputs. But if there's water on a farm, we're going to be trying to measure it in some form or fashion, not just edge of field, but farm ponds, reservoirs, and creeks and streams that run through it. Although we're not doing as much as that as I would like, but it's something that we do look at. So we're going to focus on our cotton farm today, where we have a lot of good data. I know this is not a crop that you grow in Vermont or Minnesota or Wisconsin, but it's certainly still a major crop in the South. And it's something that we're looking at, the runoff from cotton. And so this is the farm that we've been on. These are the 4 fields that we've monitored. These 2 fields, this is Shopcott and Weaver, these 2 fields had cover crops. The Welcott and the Home Place fields did not. And it's kind of interesting, but these 2 fields here are much longer. The row length is much longer. And remember, we don't have a lot of slope on these fields. And these fields, a lot of our row crop fields can be a half-mile long. One of the things about these soils, though, you see these old remnants of kind of oxbow lakes or sloughs, the meandering, because we don't have much slope. These streams tend to meander, but they deposited a lot of very fine soil particles. And so we have heavy texture soils. We don't get a lot of movement down below 6 inches the way that we've been farming this. So we primarily farm the top 6 inches of soil. And we're going to talk a little bit about what we've found using cover crops from both the water quality standpoint, but also how it's helping us open that soil profile up. And the cover crops, we've only used a single species, ryegrass, but I'm going to let Bill talk a little bit more about that. But just know that our drainage problems are we can't get water to move through down to tiles. So we have to do everything from a surface runoff standpoint to get drainage. I just wanted to go through some of our losses on these fields. This is over 5 years worth of data. And we didn't have enough fields to use as reps necessarily to compare row crops, fields that had row crops and no row crops. But what we thought we could do is get some insight by comparing the condition in that field and seeing if we saw something different, hoping that the hydrology would be similar, or at least we could see the effect on hydrology within a single field, as we know that hydrology can vary greatly among fields. So I remember this Dumas 2 and this Dumas 3, I called them something else, but these are the two fields that had row crops. We did not try to compare fields. We tried to compare within the field. So what you see is we have the growing season and we have the irrigation. And we have the growing season and we have the precipitation events. So we broke those out. And then we have the non-growing season and the precipitation events. And the reason we did it this way is if you look at the non-growing season, you can compare that to the time we wouldn't have cover crops, but we might have, they've been terminated. We might have residue out there, but the non-growing season is when we had active cover crops growing. So the statistics you'll see here are for different times and different conditions in the same field. What we found is that we did see a difference with cover crops. It did reduce nitrate concentration for both in the water and also total in the water. It was significantly less than what we would have for the growing season with precipitation. Both were significantly, well, the cover crop was not significantly different from irrigation events, but they were significantly higher for the rainfall events. And so we're seeing that irrigation, the way we trickle water down our furrows a half mile long on slopes 1 to 2%, it's not generating the velocity and removing some of the nutrients, even though they may be soluble, that we're seeing with the rainfall, where we get the more intense and the furrows fill up instantaneously from top to bottom. But when you look at putting it on a pounds per acre or taking the concentration and looking at the loading based on the volume of runoff, we don't see any significant difference. And so we see significant difference and decreases with cover crops in the concentration. But I think what's happening is our hydrology is at an order of magnitude greater than differences in concentration. And that just, we lose any treatment effect because of that, because of these. And really what's happening is we can get huge runoff events during the wintertime. We don't get much snow at this location, but we can get some big runoff events that carry just flushing type events that it may not be as high a concentration, but it certainly can carry with the volume of water running off can create a bigger load. We see the same trend, almost the exact same trend in the other field, the Weaver field or Dumas 3. During the season, we get a lot less concentration, but again, that load in nitrogen is not significantly different. But and when you look at the field that didn't have a cover crop that we included in this, you see that we actually had some significance between, it was a little bit higher during the non-growing season. And that may be simply, we don't have a cover crop out there. We still have some nitrogen left in that profile that can interact with runoff. And but again, we didn't see it in the load. If we look at phosphorus, again, the same setup. This represents irrigation. This represents the growing season without a cover crop during that time, and then the non-growing season with a cover crop. We did see differences between the irrigation, but not between cover crop and no cover crop, between the growing season and the non-growing season in terms of concentration. So it's a little bit different trend for phosphorus. We did see that the irrigation was significantly less loss of phosphorus than it was in either situation produced by rainfall. So the rainfall is obviously in some manner interacting better with or more with the phosphorus, being able to take it along with it down the furrow than what we're seeing with the irrigation. Dumas 3, same trends here. Again, no difference between the precipitation events, but there is with the irrigation, but we don't see that effect in the cover crop in the non-growing season, we don't see that it's reducing the concentration. We did have one field that did reduce the concentration. The concentration of the non-growing season, we saw an increase, a significant increase during the non-growing season when we had the cover crop out there. For the field that didn't have the cover crop, again, these things, the same trend for phosphorus. The numbers were numerically higher, but they weren't significantly higher. One thing that we've been looking at also, and I bring this up, but we started looking at potassium in runoff. We don't acknowledge potassium as a water quality issue, but because we had the infrastructure and we felt like we ought to look at it to see if it might help the farmers' profitability. And over this 3-year period that we did this from 2000, well, this is just 2019, but we've done it for 2017, 18, and 19. But we saw the same type of trends. And I chose to use 2019 because the potassium fertilizer applied in the blue was the same amount for each field. And the other fields, the other years it differed. And we can see that we've lost about 25 pounds per acre cumulative throughout the monitoring period. And that's about 34% of what we applied as fertilizer. But now let me say this about potassium. We made it relative to the fertilizer just to give it perspective, but that doesn't mean that potassium that we're getting necessarily is coming from the previous fertilizer application. Potassium does not get incorporated into the cell level in plants. It stays in the it stays really in the liquid portion of the plant. So when that plant material dies, it's easily leached out. And we saw that a lot of our losses came in the wintertime when we had big storm events, big runoff events, not necessarily big precipitation, but big runoff events, because our soils tend to get wet in the winter and stay wet, and it doesn't take as much precipitation to generate runoff. Now, I bring this up because, again, Stevens 2 and 3 were in cover crops. Stevens 4 was not. We saw a little more loss, about 12%, I'm sorry, about 8% more in Stevens 4 of potassium. And so the reason I bring this up is first of all, it equates to about $15 per acre based on current potassium fertilizer prices. That's significant. The loss is equivalent to what we would need for a really good cotton yield. And so if we can figure out a way to keep that potassium in place, even though it's not a water quality problem, it is a profitability issue for that farmer. And so we are going to be tomorrow with our Discovery Farmer and with Cotton Incorporated and others to discuss where do we think we can make management changes. And I do think that cover crops may have a place in helping us recycle that potassium, but we may have to learn how to manage it, and we may have to look at some different cover crops than just cereal rye. I also wanted to talk about the fact that our cover crop fields, and this is not fields from that location, it's from another, but it is to illustrate the point. One thing we noticed using cereal rye is that we tend to get this idea that the profile and those compaction layers get broken up so that we can get better cash crop root growth deeper in the profile. And we use these soil moisture sensors, and Bill's going to show some data from our field, but this is with cover crop. And what you notice is at the 6-inch depth, we get these fluctuations with, we start to dry out, and then we move down toward a rainfall or irrigation. We'll move back down close to saturation, then we'll dry out. And we see that kind of that same effect going on, but just dampened a little bit at 12 inches. We also see it at 18 inches. Dampened. And then at 30 inches, not quite as much, but there is some movement. But when you look at the without cover crop, look at this, the 12, 18, and 30 inches. It's just kind of a flat line across there. It does not respond like the 6-inch, which tells us that where we have cover crops, our cash crop roots are getting down and utilizing water deeper in the profile. And that means it also is probably accessing nutrients deeper in the profile than without cover crops. This is very important to us because we think if we can get the roots down to 30 inches, we can use water from that depth that we've not been accessing before. I'm not saying we're getting more water down there. I'm saying we're letting the cash crop access that water. And Bill will show some data where we're actually showing we're getting more water down there. But the fact of the matter is, if it can save us an irrigation or two, that's a tremendous savings on first of our groundwater. If we get this on all the acres, and reduce an irrigation or two, where we average 4 to 6 irrigations, a year, then that's significant for us and a significant profitability for our farmers. And so cover crops are playing a role of not only improving maybe water quality, although our results are not as conclusive as we'd hope, but they certainly show potential for reducing runoff. And why do I think that's important? Well, if you look at the runoff on some work that we've done from those fields, and this combined all data across all fields, but you can look at the loss of nitrogen in terms of kilograms per hectare, and then runoff, cumulative runoff. Now, this was only for growing season. From time of planting till the end of October. We don't have our winter data in this. And what we found when we add our winter data, we're not getting these nice linear relationships anymore, because we can get unproportional losses with heavier runoff. But if for in fact that we do find that at hard times of the year, from say April 1st to October, that we are getting linear losses, so that as the runoff amount increases, so does the amount of nitrogen loss. And these are decent R squared values. Then that's telling us that, it's not always about controlling the source. It may be about trying to manipulate the hydrology some, and using cover crops to do that. By where we increase infiltration and we're reducing. And we have taken infiltration measurements. I did not mention, but we're doing cover crop versus no cover crop without the water quality monitoring, but just looking at the depth of penetration of roots and soil moisture extraction at several different locations, satellite locations to our discovery farms around the state. We found the same thing for phosphorus during this period of time, from about the 1st of April to the end of October. Again, even stronger linear relationships. But to me, this indicates if we could somehow figure out how to hold some of that water in the field and not let as much of it run off, that we could help reduce nutrient losses in that field. This is very hard data to get at. This was 5 years worth of monitoring. This represents 19 site years, and it's your regression is always going to look better when you have, when you have a lot fewer points. So this is hard data to get at, to try to make sure that you get the cumulative amounts over that period. With that, I'm going to turn it over to Bill Robertson and let him talk about some things he's doing on our discovery farms related more to sustainability and profitability, and how cover crops play a role in that. So Bill, go ahead.
Mike, can we take 1 second to answer 2 questions that came in through the chat?
Absolutely.
All right. Just because I don't want them to get kind of lost behind. So were there any specific factors like slopes or soil types or conditions that you look for that determine which fields receive cover crops versus the fields without?
Well, I think Tim said something very important. When you get on farms and you're working with farmers, we never go onto a farm and say, this is what you ought to look at, or this is what you ought to do. We had the 4 fields that we were monitoring, and quite honestly, our farmer chose these as the 2 fields that he wanted to have cover crops on, and the 2 that he didn't, for whatever reason. So, and that was another reason we didn't necessarily try to separate out, was this field different from that field in terms of cover crops. That's why we tried to look at differences within the year. And it's tough. I think Tim's right. The great thing about discovery farms and being observational data like this is really when our researchers see this information, it starts their thought process of things they might need to do or look at on our research stations. And so we kind of try to verify the research going out, but in the same time, when we get our results, it's as we're getting more questions than we're answering sometimes, and it's really prompting a lot of research ideas. And so I think we're going to see more researchers, looking at our data to decide where to go next on that. So we did not really choose. And Bill may have more insight on that, on why Steve chose those fields compared to the other two.
Okay. The second question that came in is, what do livestock producers in your area do with their animal waste if they don't also have cropland?
Well, we've had our poultry farmers a lot of times in the past would apply it to their pastures, and that would be their only form of fertilizer, the poultry litter. With the lawsuits and the concern over runoff because in permanent pasture, and when you apply that poultry litter, it doesn't always get incorporated, and it does. We have seen a lot of studies that show we can get increased phosphorus and runoff of pastures treated, especially with our higher slopes. Our P-index limits now the application rate. It checks for the risk associated with slope and stuff. So we've seen a tremendous amount of that. The state helps subsidize a program to transport that litter to row crop ground. And what we've seen is that we've had, lots, as much as half of the litter generated, like in the Illinois River watershed, being transported to cropland in Kansas and Oklahoma. We don't have cropland in that area, but not far from there. Unfortunately, it's not economical to take it to Eastern Arkansas. But we've had new poultry companies come in and establish poultry operations and poultry producers in Eastern Arkansas. And so we've got a discovery farm for utilizing poultry litter on row crops now, because it's going to become more accessible. I think the idea of our dairy is that he minimizes rinse water in his parlor. He dry scrapes, he composts that material, and then he's using a passive solid separator. And then he's got a trench that he puts the wastewater in, but most of the solids have been removed by that time. And we're just watching and taking soil samples every other year at certain distances from that trench down slope to see how the nutrients may be migrating down there. I don't have that data, but that's where our livestock producers are faced with now. Is they still they use reduced rates on their pastures, but they are transporting a lot of the dry waste, poultry litter out of the watersheds.
Okay, great. So let's go ahead and have Bill present, and then we've already got a couple more questions for the end of the Arkansas session.
All right, I'm on board now. This is Bill Robertson. This is a slide that Steve and I have used, and Mike's been part of this presentation. I really like working with Steve, and I know Mike does too, and he kind of fits the mold that a lot of the other discovery farms have used with the bell cow type growers that like to get up and tell other farmers what happens. But this is a slide we use in like producer to producer meetings. A lot of times, some of the meetings I go to, they have a farmer paired up with an extension person or a researcher. And these type of meetings have been very effective, some of my favorite meetings. But Steve has recently passed the reins off to his son-in-law. He's got over 40 experiences farming, not 40 years of experience, but 40 experiences farming. But when Steve thought of this and pursued this with us, it was something that he really wanted to do, because he's really concerned about conserving water, like Mike Daniels talked about a while ago. So he does a lot of things. He wants to ensure that his kids have the water there, his kids and grandkids to farm the way he's farmed. So he does, next slide, Mike. So he does a lot of things to try to be more efficient with his water and to waste less water. And he was really big on the faucet program. It's we irrigate cotton furrow irrigation with a plastic pipe. And this is a program designed to help decide what size hole to put in that pipe, and it's based on pressure and row length. And so that has really reduced the amount of waste that he has with his irrigation and translates directly into the saving of fuel costs. Mike, next. And so a lot of this in terms of being more efficient with his water and all that boils down to soil health. And that next, Mike. If we look at how we farm cotton, this is very typical. As you know, we want to start off clean and stay clean. Cotton's a very poor competitor early. So a lot of our fields are completely worked. Very little soil structure left there in those fields, no weeds, and it runs into a lot of issues. If you look at the bottom right, you see a picture of that field with water running down the furrows, and a lot of times due to our lack of soil structure, slow infiltration rates, the water just the wetted front does not soak all the way up to the top of the row. Go, Mike. And when we look at some of the tools to look at our level of sustainability, I know our cotton supply chain is really wanting to be able to document that they source sustainably produced fiber, and that's what's driving a lot of this. And so Field to Market Alliance for Sustainable Agriculture has part of their field print platform, this field print calculator. Basically put almost everything you do during the season in, and that shaded area is basically your environmental footprint when you look at the different metrics for sustainability. And when we farm the way that picture depicted, that's kind of what our environmental footprint typically looks like on cotton. Next. Then, and a lot of what it drives our lack of water infiltration, and reason why I might talk about that we don't have tile drainage. Next slide, Mike. Most of our silt loam soils are what we have where we grow our cotton. And if you look at water infiltration rate, it's 1/2 inch an hour. So it's no wonder when we have our big rainfall events that it all runs off the field. We don't get much into the soil profile. And we've seen in some of the fields that after we've been in cover crops, even just a straight soil rye cover crop for 2 to 3 years, we go from 1/2 inch to 1 inch an hour, depending on the moisture of the soil. We can go to 6 to 8 inches and sometimes even more of infiltration rate an hour. And so that really does a lot. And Mike, you know, in the Discovery Farm field with Steve, we measure the water coming out of the well. We know how much water run out of the field. And a lot of times we see about double the amount of water infiltration, or double the amount of water going into the soil profile where we have the cover crop. Next slide, Mike. So when we look at trying to ensure that we have improved soil health, one is to armor the soil, keep it covered. The second thing is to have growing roots in the soil as many months out of the year as we can. And we try to do that with the covers, with our crops, and even in our pastures, we try to do that. And then increase diversity. We need as much diversity as we can in our cash crops, and we need as much diversity as we can in our cover crops. And that's one area where a lot of times you get a farmer started on cover crops. Cereal rye is like the cover crop with training wheels. It's easy to establish, and it's easy to terminate. But we need to evolve and diversify that. And we see there's kind of an issue with kind of some of the sun that we've seen here. But these first 3 things, in my opinion, help build soil structure. So the 4th thing here is disturb the soil as little as possible, especially with deep tillage, because building soil structure is kind of a slow process, but we can destroy soil structure really quick. And I think of those things like a 4-cylinder engine. And I know a 4-cylinder engine, you know, we need to have all 4 cylinders running, but I know a lot of people that are doing 2 of those things, and that 4-cylinder engine just won't run. But we have some people that are doing all 4 of those things, and then some of them are even introducing livestock into the equation. And I feel like that's like slapping a turbocharger on a 4-cylinder engine. Okay, let's go to the next slide, Mike. So, you know, when we look at an acre of healthy soil, there's, you know, 10,000 pounds of biological material there. And that's about the same as 2 African elephants. And so we have to feed those elephants to keep them strong and growing year round. Next slide, Mike. And so that's one of the biggest things that I do with a cover crop. Now then, we've talked about big biomass on cover crops, and all these pictures are straight cereal rye. And I've seen that we can have too much because our carbon nitrogen ratio on mature cereal rye like this is like 80-1. And you think about what kind of, if you're going to bale that and feed that to a cow, look at crude protein. Crude protein would be less than 8%. You would starve a cow to death feeding her that hay. When we have poor quality hay like that, we have to put lick tanks and other things out there. You look at a lick tank, what does it have? It has molasses for energy. It has urea in there for nitrogen. And so we have to keep that cow, keep the bugs in her gut, in the rumen going. And so we'd have to do the same thing in our soil. And so when we get cover crops this big, and I really cut my teeth on cover working with Steve on this because he was learning, I was learning, we were all learning. But we don't need that big biomass if we're going to have straight cereal rye and planting green. Now, some people want to plant green. And if you're going to plant green, you better have a lot of diversity. You better I think of it as what is going to be growing out there whenever I terminate it and plant it, and what kind of hay is it going to make? Is it going to be good hay or bad hay? And so I want to have enough diversity out there that I have good hay. So let's go to the next slide, Mike. And so when we do these things and we look at, remember our field print, our environmental footprint on where we have the till and the no cover crop, and compare that to our environmental footprint where we have the no-till and the cover crop. We have greatly reduced environmental footprint. And so that's exactly what the supply chain wants. And what the farmer wants is to be more profitable. And so we try to line, in my program, I try to line those things up to give the supply chain what they want and then help the farmers be more profitable. Let's go to the next slide, Mike. And so when we're doing this, I get the farmer to go out. Here's the top left image is the no-till with a cover crop. The bottom right is where we did a stale seed bed. There's some tillage in there, but we did plant a cover crop behind his last tillage to bed it up. That cover crop is a little bit later. But even the little bit of tillage we did after a big rainfall, we still see some differences in water infiltration. Up on the top, where we do the cover crop and the no-till, it just like this soaks the water up like a sponge. And so that's something easy for the farmers to see. And I get them to look at that. And oftentimes when the water's running off the field, I get them to get a water bottle and get a sample of the runoff. And one's clear and one's pretty cloudy. And Mike has done the analysis on some of those things. Let's go to the next slide, Mike. Here's typically what we see when our cotton's young with a cover crop. And having diversity out there helps us with the more diversity we have, the more diversity we have in our beneficial insects, the more diversity we have in beneficial insects, the less we have to spray, and we can do things to try to preserve those insects. But in a diverse cover crop before planting, oftentimes we see 80-1 beneficials compared to pest. And so there's some real things we can do by having that cover crop and building teamwork and doing more than just improving soil moisture. And I think that's going to kind of lead us into regenerative agriculture practices to where we get that teamwork, and then we can spend less money on our cotton crop because the cotton crop is so much more efficient. Let's go to the next slide. We're running out of time, Mike. And so basically in these, I called it no-till, but basically it's almost no-till. We run a fur runner plow. Because as Mike mentioned, basically the only drainage we have is external drainage, water running down the row off the field. But when we improve our internal drainage, get more water, then a lot of times in cotton, we still need just a little bit of help with external drainage, but not much. And this plow really gives us all the assistance we need for cotton, because cotton doesn't like wet feet. Next slide. And so here's a tractor with it's only a 6-row. I had one that I could haul around across the state to do different ones. And then there's Steve running his water furrows prior to irrigation on the bottom right. Next slide. But when we look at the Forerunner, you see on the top right, you see the residue still there. We don't see bare soil, because when we have bare soil, then we're gonna stimulate pigweed germination. And so the idea is to run that, give us a little bit of help on external drainage, but not have bare soil. And even when he had stale seed bed with a cover crop, by the time he run his water furrows the conventional way, you see very little residue out there. We've lost soil structure, and we have the negative impacts of poor water infiltration. Let's go to the next slide. And this is kind of what Mike was talking about earlier. Here's a slide that The blue line is our 6-inch sensor. A lot of times I put a 6, 12, and 18-inch sensor. A rain, we see one big rainfall event. We saw some movement in the deeper depths. But when we get into a single irrigation and a single rainfall event, a lot of times the 6-inch sensor is the only one that knows something's going on. Next slide. But on the cover crop side, we can see movement in the 6, 12, and the 18-inch sensor. And in my mind, where we're getting water deeper, we're having more active roots, and where we have more active roots, we get make life a lot easier on the cotton plant to get the moisture, get the nutrients that it needs, because the shallow root system just is like handcuffing the plant. Okay, Mike. So when we look at yield, we see a little bit of increase in yield, about a little over 5% increase in yield going the no-till cover crop. And a lot of times that's due to improved water infiltration. In a dry year, I've seen almost a 10% increase in yield. In a wet year, almost nothing. Now, when we look at this, there's kind of some issues we run into on some of this research, and other people have talked about this too. Basically, if you look at how much we spend on an acre basis, basically you add the cost of the cover crop, because we're doing exactly the same on both sides. Sometimes we save irrigation, sometimes we don't. But I think part of that is because we just have a single species cover crop. In some other research areas or some other research fields that I'm doing work and looking at a very diverse blend of cover crops and all that, we're spending less money. A lot of times $150 to $200 an acre less money. We're making the same or more yield. And so that helps us improve our income and improve our expenses. But even in this situation, if you look at our expenses per pound of cotton produced, then we had a savings of about 5%. But in our land use, our irrigation water use efficiency, energy use, greenhouse gas emissions, we're seeing advantages going with the no-till cover crop. So this is heading in the right direction. But I think we can do a lot better if we improve our diversity. Next slide, Mike. And so, the U.S. cotton industry has set goals for where we want to be down the road. Next slide. And so what we're seeing here is in Steve's field is getting us in that direction. Next slide, Mike. Okay, there's several soil health indicators. Earthworms is a good one that I target for producers to look at. Something that I've tried to do is on the next slide is a takeoff from a farmer, Blake Vince in Ontario, Canada. Soil your undies. Y'all need to look at YouTube's videos on this. But basically, it's a takeoff on the cotton strip test. But the more active your soil microbes are, the more tattered and torn the cellulose is in a pair of cotton underwear. And so there's oftentimes 5 weeks after I've buried the underwear in a cotton field, you go back out, the elastic's the only thing showing. On the side where we didn't use a cover crop or using tillage and all that, you dig the underwear up and it's just dirty. And so that's a real eye-opening experience for producers. Okay, Mike. And so, we have, if we're going to stay in business, we have to adapt to change. That's the name of the game. Next slide, Mike. Mike, these are some of the things that were in your presentation. Do you want to talk about this summary?
Yes, I couldn't find the mute button. What we saw from a water quality standpoint on this particular farm is cover crops significantly reduced in concentration and runoff, but not the loads. And again, we can get some big variability in our runoff that may mask any treatment effect, or at least with this data set. It did not significantly reduce P in concentration and runoff or loads. We think that it may help, but we're going to have to learn how to do it in reducing K losses and runoff. And then we're also seeing that during the sampling season that we used in the one study from 1st of April to end of October, that the cumulative seasonal losses are linearly correlated with cumulative runoff volume. So if we can reduce runoff volume, and which is hard to do, but we think we've shown some data we think shows that we can do it with cover crops. But those were kind of the water quality things, and I'll let Bill talk about his.
All right, we talked about the deeper water infiltration. Mike had data on that, and I did too. If you look at expenses per pound of lint produced, and we did have some savings there. And the cover crops and the no tillage does get us where our supply chain wants us to be with sustainably produced fiber. Let's go to the next slide, Mike. So here's my contact info, and just going to the end, Mike. But I'm sorry, went up way over on time. But anyway, that's our kind of what we're seeing with the cover crops in Arkansas. I think we got a good start. This is just a start of good things to come down the road, I think, when we really improve our diversity. Thank you.
Awesome. Thank you, Mike and Bill. Really great information. And it's definitely a different cropping system that I'm looking at out my window at the moment, but really interesting to learn about for us in the north. So a couple questions in the chat here. We've got about 5 minutes left in this section, so we're doing real well on time. Okay. This one came in during Mike's presentation. Do you have any hypothesis for why cover crops were not statistically significant in improving water quality?
I don't, especially on what we've read in the literature is that, especially up north, there can be, when you go through freezing and thawing, there can be release of phosphorus from the cover crop material. We may be seeing some of the same thing, that we uptake these nutrients, and then when we terminate our cover crops, you've got nitrogen and phosphorus in that plant material. And we can have some very warm, wet spring days, just perfect for microbial activity. And we may be seeing some mineralization going on, and then losing that, losing those nutrients from dead plant material or residue. So we're not sure. It wasn't as clear cut as we were hoping, but when you review the literature, you find that, and I also think we haven't looked at sediment yet. We did collect total suspended solids, so we're going to look at that. But again, I think it's maybe not as a big a difference on this farm, where we do have the long rows with, at most 2% on one of the fields. Most of the time it's between 0 and 1% slope. We just don't have quite the same issues that you might have in the Midwest, where you may get the rolling hills and a little bit more slope in terms of sediment loss and nutrient loss down the rows.
All right. Yeah, it's difficult. There's so many things at play, right? One question about irrigation. If you have limited irrigation water, why are farmers still furrow irrigating instead of overhead? And some of the benefits and challenges of that.
Bill, you want to take that one?
Yeah, a lot of times we do a better job of getting water into the soil profile with furrow irrigation. Typically with a sprinkle irrigation, overhead irrigation, I consider I see about half the amount of water going into the soil profile with an overhead sprinkler. For instance, a lot of times if we try to set an overhead sprinkler to put out more than about 1 inch of water, it all runs off. We just cannot get more in the soil profile than about 1 inch with a single rainfall event. A lot of times with furrow irrigation and watering every middle, then we can get about 2 inches of water into the soil profile with effective irrigation.
Amber, I think another thing affecting that, quite honestly, is this poly pipe is much cheaper, much more labor savings, much easier to lay out. You don't have the high overhead cost of the center pivots that we use in some parts of the state, and it's less maintenance. And really, one person now can go through there and lay out that poly pipe with a tractor, and then just go back through and punch the holes. So it's really a cost saving manner. But the thing is, we have found that on Steve Stevens' farm, by being able to measure the runoff, and showing him what his bulk irrigation efficiency was, of how much of that irrigation water stayed in the field. Now on furrow irrigation, to get the whole field watered, you're going to lose some tailwater at the bottom. You just can't avoid that. But he's been able to minimize that with this faucet program that lets the rows water out evenly and you know, and more quickly. And the fact of the matter is, he's up around 90% irrigation efficiency. So in other words, 90% of the water he puts on his irrigation, he keeps in the field, which is phenomenal. We never thought we could get there in these furrow irrigation systems, but with cover crops and other things, we are pushing that. Doesn't mean they always do, but they've gotten up to that mark.
But with land forming and all that, it makes furrow irrigation a lot better for producers. There are a lot of center pivot irrigations for sale in Arkansas. So if you're needing a center pivot irrigation system, you can find one here.
Take a road trip, right?
Yeah.
Okay, so one last question for you guys, and then I see that there is at least one that I'll ask you to just type and answer in the chat. So given the soil conditions and no frost, how does that affect the ability to increase soil carbon with greater decomposition rates of residue?
I didn't hear the first part of your question, Amber.
Yeah, so what Ben is asking is, given the soil conditions and no frost, so what he's saying is, you know, that decomposition happens so quickly by you compared to Wisconsin and Minnesota, how does that affect the ability to increase soil carbon?
Well, I think we can answer that by looking at what our soil organic matter average content is, you know, and we can have organic matter content down as low as 0.5%. And we don't get much higher than 2 to 3% without really trying hard and making sure we're adding organic sources year after year after year. I think it's a myth, but it's generally accepted that we're not going to increase our soil organic matter much because of that. But I don't think we've tried. I don't think we've given it we haven't made that a goal because we just believe this myth, because being in the South with the decomposition rates we have. But I think if we add enough carbon source, I think we can see improvements. And even if we improve 0.5% of organic matter, we've done a lot for our soils.
Right. All right, awesome. Thanks so much, Bill and Mike, for your information. There's one more question in the chat, if you wouldn't mind typing an answer to that. And we are going to move on to our last state represented today, smallest in area, but certainly not in impact, right? It's time to hear from our partners who started up the Discovery Farms program in Vermont. So our speakers from Vermont will be Dr. Heather Darby, Dr. Joshua Faulkner, and Ivy Krasinski. Dr. Heather Darby is a professor and agronomist with the University of Vermont. Dr. Joshua Faulkner is a research assistant professor and coordinator of the Farming and Climate Change program at the University of Vermont. And Ivy Krasinski is a research specialist for the UVM Extension Northwest Crops and Soils program and is the lead for coordinating Discovery Acres. So go ahead and take it away. Oh, I'm sorry. I think, were we going to try to launch that poll, Tim, or not?
Yes, I just launched. We were going to launch a poll at the beginning, so we'll just launch it now. There'll be one at the end too.
This just helps us, if you wouldn't mind answering this really quick, it just helps us in our reporting and for curiosity's sake, and to just continue to refine our outreach efforts. So if you wouldn't mind quickly answering that poll, and then Heather, if you want to get started.
Sure, great, thank you. And as Amber already mentioned, we are the most recent state to join the Discovery Farms Network. And we also happen to be the smallest state, as she mentioned, but we don't have little state syndrome. We actually believe that we are large at heart, and we're having a significant impact on water quality and climate in Vermont, and with our work that we do with farmers in Vermont. And we're going to share some of that today. So Amber already introduced some of the members of our Discovery Farms team. So myself, Joshua Faulkner, and Ivy Krasinski will be presenting today. But also Jeff Sanders, who's an agronomy outreach professional, plays an important role on our team, as well as Lindsay Rule, another research specialist, and the Bassett family that is the landowner and operator of the dairy farm where our Discovery Farms site is located. So I thought I would take a little time to introduce our primary production system in Vermont, which is dairy. So dairy is the leading agricultural industry in our state. And similar to what Matt had already talked about, because of that, our primary crop that is grown besides forages, besides that perennial cool season forage, is corn silage. So corn silage makes up a significant portion of our cropland in Vermont. Actually, I think it's about probably 90% of all the row crop in Vermont is grown for corn silage. So you can see over here our land use practices. Again, our cropland. This is all the cropland in Vermont is a little over 90,000 acres. And again, most of that in corn silage production and a much smaller amount in corn grain, most of this being high moisture. And we have, several thousand acres of soybean. And then, the rest of the annual cropland in Vermont is vegetable crops primarily. But again, dairy is our primary industry, and the crop that we're working with to integrate cover crops, of course, is the corn silage system. Of that acreage, you can see we do have a pretty significant portion of it that's tile drained. A lot of the agricultural land in Vermont is very heavy and wet. Lots of really poorly drained clay soils. And as a result of that, I would say just in the last 5 years, we've had a significant portion of that land go into tile drainage. We also have lots of conservation practices being implemented on our landscape. And you can see, even though we're small acreage, over half of our corn silage acreage is cover cropped, and that's quite substantial. It's all relative regardless of size, but for us, that's been quite a significant feat. We have a growing number of acreage in no tillage. That again is also kind of a recent development for us as our farmers have gained confidence in using no-till in our system. And also, of course, because a lot of that land now is being tile drained, giving us the ability to actually better implement some of these conservation practices. So just setting the stage a little bit about our agricultural system in Vermont. Seems to be a delay in the slide change. There we go. So I'm going to turn it over for a few minutes to Joshua Faulkner.
Thanks, Heather. I'm just going to further set the stage for some of the need for the cover crop work and Discovery Acres work that we started here in Vermont. And a big factor in that are environmental concerns and primarily phosphorus runoff. And we're looking at, on the right-hand side of your screen, you see the blue there is Lake Champlain, which divides us from New York State. And you'll see the yellow there on that map. That's all of our agricultural land. And most of that is clearly concentrated in the Champlain Valley, pretty close to the lake. And so, as you might imagine, that could create some issues having that much of our dairy production within that proximity of freshwater, large body of fresh water. It's like many freshwater bodies, it's limited in phosphorus. So when we see phosphorus entering that water, we see eutrophication and harmful algal blooms. It's really a big economic generator for the state. So there's a lot of focus on this issue with phosphorus. About 40% of phosphorus going in the lake comes from agriculture, and we're charged with about a 36% reduction in that phosphorus loss through a TMDL set by the EPA. And then at the state level, we have new regulations called the required agricultural practices, which are, kind of go hand in hand with the TMDL, but extend outside of the Champlain Basin as well. And I guess, as this is related to Discovery Acres, this has really created a large opportunity for farmers to receive financial and technical assistance for cover cropping, and is driving a lot of our programs, not just cover cropping, but other conservation programs as well. Next slide, Heather.
Hear you. There we go.
Okay, great. So, the other factor for us, of course, is like Minnesota and Wisconsin, we're a cold state. We have a very a shorter growing season, and deep, dark, cold winters, which in the context of cover crops, of course, create some issues for overwintering. One example is overwintering of some cover crop species, but this is something we're always fighting against, these cold conditions in Vermont. Next slide, please. We are also tremendously wet. I should have said this on the last slide. These black lines show the top 50 corn silage counties in the country. And we are a little state, but we have 3 of those counties here in Vermont, and all of those are cold and wet. All of those counties average over 40 inches of rainfall a year, which also creates challenges, especially in the spring for termination or harvest of cover crops, and then in the fall for ensuring that we can plant cover crops without causing soil damage. Next slide. And then these precipitation issues aren't getting any better. We know that the climate is changing in the Northeast. Overall, we're seeing about a 4-inch increase in annual average precipitation over the past century, and that's what I'm showing there with the blue trend line. But then when you drill down into the Vermont specific data, we see a very different story, especially when you look at the past 30 years. We see increases in annual precipitation of 5 inches, 7 inches, 9 inches, and that's 100 inches over, or I'm sorry, 4 inches over 100 years. That's multiple generations on a farm, but 9 inches in 30 years, that's one generation on a farm. So that creates a lot of challenges for our farmers as well. Next slide. And then it's not just that we're getting wetter here. It's that the patterns of precipitation are changing. We're seeing a lot more of these heavy storms. This is a figure from the last National Climate Assessment, and the Northeast is seeing a 55% increase in these very heavy precipitation events. So over an inch in 24 hours. And this is something that you hear, with every farmer that you visit, that they're really struggling with how they're going to maintain soil health and prevent erosion because of these really heavy storms that we're seeing more of. Next slide. And as you might imagine, these heavy storms do cause issues for farmers. This is just me standing in with a silly grin on my face as a soil and water engineer. This is, something I'd really only seen in textbooks, and to visit a farm and stand in a gully about 3 feet deep was kind of a special moment, but really sad for the farm. And as you might imagine, these storms just lead to not always erosion at this scale, but a significant erosion. And so we're looking for ways to hold that soil in place, and cover crops obviously might be a good tool to do that. Next slide. Back to Heather.
So we're setting the stage to show you how difficult it is to grow crops in Vermont, let alone for farmers to think about then adopting all these new conservation practices, including cover crops. There are real barriers, real challenges. There's also perceived ones, but nonetheless, in order for us to get to that level of cover cropping that we have today and hoping to go even higher, we've had to overcome those real and often sometimes perceived challenges, you know, this short growing season, these heavy clay soils, people that, you know, still want to fall till because of that heavy clay, limited time in the fall. We have a manure spreading ban here. We can't spread manure past certain dates. And we have the additional cost involved with all this and other barriers and more management, more things to do and more things that can go wrong. So working with our farmers to overcome these challenges has been the brunt of our work. There are thousands, if not tens of thousands, of research papers that have been published on the benefits of cover cropping. But, you know, we have to get the rubber to hit the road. And the research that all of us do is really great. But if we can't implement that research and observe and actually see the benefits that we see in the research, then in some ways it's all for naught. And most of the work that we have done here in Vermont to gain that amount of cover crop adoption has been our focus on working with the farmers on the agronomics of cover cropping and the agronomic benefits. And although there is research to support that there's water quality benefits, soil health benefits, pest management benefits, that hasn't been our focus over the last decade, which is, I guess, how long we've been working on this, more than that actually. But now, and Joshua corrected me today, he's like, but now in the last couple of years, we have been really focused on trying to quantify the value that cover crops have to our environment. And that's really important. It's really critical, not just to continue the drive that our farmers have to do this, but to see hopefully that we're making a difference in water quality and also what we can do better to enhance that potential benefit. So this is just a list of mostly current projects that we have going on to quantify the benefits of cover crops on water quality. And that is part of the focus of our new Discovery Farms program here. But I wanted to talk a little bit about all of the agronomic and agronomic benefit research that we have done, because this is really, I feel like, how we've gotten farmers to adopt cover crops is really looking at how to overcome those challenges. And we've done this through, you know, small plot research, on-farm demonstration, on-farm research, and technical assistance. So we've had this corn silage cropping system study going since 2005, and it continues on today, where we're looking at different corn silage rotations and systems. And we have one with corn silage with a winter rye cover crop, and this is very, very common in Vermont, compared to continuous corn. And continuous corn in Vermont is a practice, not that we love it, but I will say we have a number of farms that have actual just 2 cornfields because of the landscape in Vermont. So continuous corn, unfortunately, is a real rotation, and we've been evaluating that with winter cover crops, winter rye in particular, as well as comparing that to no-till. And I have this NC here, which is kind of new corn, meaning just rotated out of perennial forage. And I just want you to look at this yellow line here, which is that continuous corn with an added winter rye cover crop. And what we see here in Vermont is the benefit of doing that for yields. And this data actually only spans from 2014 to 2017. And as I mentioned, this project has been going on for quite a few years now. And really, we basically see over all of that time about a 2-ton, a little less than 2-ton corn silage yield increase. And our farmers also have observed this in their fields as well. So for us, we generally do see a yield improvement by just even using that winter rye cover crop. We've also tried to show the benefits of using these winter rye cover crops to soil health. And again, we haven't seen, with these soil health indicators, huge differences in soil health from just using a cover crop. So we don't see big increases in organic matter levels. We don't generally see a lot of increase in aggregate stability or the overall soil health score. And this is all measured through the Cornell soil health assessment. But one thing we commonly do see is this sort of increase in respiration by using a winter cover crop. But again, the farmers are seeing these yield benefits, and they also report that they see improved resiliency in their soils during those really wet years in particular. And Joshua has done a lot of work, or some work, also looking at dealing with compaction, because compaction is a huge issue for us with all of those wet heavy soils, and using cover crops to break up that compaction instead of further going in with more deep tillage to disturb the soil. And again, seeing some really good results on that with our farmers. And this is a trial that Joshua had that had really high levels of farmer cooperation down into the heaviest clay soil areas that we have. So again, showing farmers the benefits is one thing. But now a lot of our time has been focused on how do we get farmers to consider the cover crop as an actual crop, as part of their cropping system, not as an afterthought, not as something that everybody wants them to do, so they're just trying to get it done, but really intentionally building it into their management so that they can produce a cover crop that provides them with the benefits that we're seeing, the yield benefits, some of the drainage benefits, alleviating compaction, etc. And this is complicated. There are lots of aspects to this, and it really means we have to do a lot of research, again, on the agronomics of cover cropping. Everything from planting to crop variety selection, to when we're going to put the manure on, to how we're going to terminate it. These are all questions that need to be answered and need to be planned for every year by the farmer to really be successful with cover cropping. And again, we've done a lot of work on this, really looking at this whole systems approach to modifying the way we grow corn silage so that we can enhance the cover crop growth and grow better cover crops so that our farmers get those benefits and also the environment. And so we have field sites all over the state that you can see here on this map where we're doing a lot of this work. And again, a big focus has been on changing the way we grow corn, selecting varieties that are shorter maturity so we can get them harvested early and we have more time at the end of the season to plant cover crops. Cutting back on our corn silage populations. We've been driving those up over the years as agronomists to get more tonnage per acre of corn silage. But when you're interseeding a cover crop, it's really difficult to get a cover crop to establish in a jungle. So working with farmers to go back and maybe reduce populations. And now also looking at variety selection. Do some corn varieties actually allow for better interseeded cover crops? So all of this work focused on modifying the way we grow the crop to get that better cover crop. And we've done a lot of the basic research that people have been talking about and referring to today, like how late can we plant these cover crops? What if we have a late year or an early year? What does that mean for cover crop biomass? And a lot of this work has been built into cost share programs and NRCS recommendations. Same with establishment. In Vermont, we hardly had a farm that had a grain drill 10 years ago. And we were really trying to encourage farmers to, again, get good seed to soil contact with their cover crop. That's how we grow good crops, not just by flinging it on the surface of the soil and hoping it's going to grow. So we spent a lot of time thinking about what tools do we have and how can we get those cover crops established. And working on interseeding a lot, from helicopters to high boys, really trying to figure out how can we get those cover crops established within our cropping system, and having those tools available to our farmers. Evaluating seeding rates that other people have talked about, and what's going to work best in our conditions, depending on the time, like depending on when people are able to harvest their corn. And again, our research has been built into the cost share program recommendations. Finally, with termination, this is big for our farmers, because as you add cover crops in the fall, that's great, you're done with it, but by the next spring, you could have a real mess on your hands if the cover crop gets away with you. And our farmers have really figured out how to embrace this. How do we manage those cover crops and terminate them and be able to terminate them regardless of what the weather brings? And having this dairy system has only really helped put value on our cover crops, from grazing and also for forage harvesting. And, you know, talking about these cover crops scavenging that nitrogen and wondering when it's going to be available back to our crops. It's a lot of work that we've also done, looking at rolling down the cover crops, to burning down the cover crops, to tilling them under. And what does that mean for the release of the nitrogen embodied in those crops to our farms here in our state? And again, harvesting those cover crops for forage has been a real win-win for us, for sure. I think lastly, as other people have said, and I also said, farmers have to be a part of this research and buying in to the solutions we come up with. And so we have had a really strong outreach program, an on-farm research program, so that the farmers are working with us hand in hand to overcome these challenges and get excited about the opportunities that exist with cover crops. And we have a lot of resources available for folks, and I think they're somewhat broadly applicable for sure. This is clearly a really old picture. I look very young there. All right, I'm gonna now turn that back over to Joshua.
Thanks. And so, you know, Heather mentioned that there's a lot of work on cover crops, but now there's I think a drive to try to put a finer point on how much cover crops improve water quality, or what other effects they may have on field scale hydrology and nutrient transport. And that led us to Discovery Farms, and we're really excited to be part of this broader network. And we got this project off the Discovery Farms project in Vermont off the ground just about a year ago. So we're pretty new at this. We installed our stations in fall of 2020, and then we had a drought this past summer. So not a lot of data yet. Avi's going to talk a little bit more about that, but I just wanted to kind of tell you a little bit about how we started and our site selection. So we went right to the belly of the beast for where we put our Discovery Farms stations. It's in the Jewett Brook watershed on St. Albans Bay, which is one of these shallow bays that has a lot of phosphorus issues. This agricultural field that we're in, we can actually see the bay from the field. And so in that particular bay, they're expecting a 24.5% reduction in phosphorus. So the soils there are representative of many of the other soils that are used for corn silage production in the Champlain Valley. The heavy clay soils that tend to crack and lead to preferential flow in tile drains. So I'm going to go ahead and hand it over to Avi now.
All right, Heather, do you want to go to the next slide? So first, I just want to highlight the partners that we work with, and it's one of the things I think everyone so far in the presentation has really mentioned, is that the one of the opportunities we have now with this Discovery Farms project is to work with not only agency representatives, but also farmers. And the Discovery Acres Advisory Board that we developed prior to creating the site, we wanted to include farmers and those agency representatives. So we have, I just want to call out the Vermont Agency of Agriculture, the Agency of Natural Resources, NRCS, the Lake Champlain Basin Program, and also Minor Institute. And the advisory board was really crucial in developing the treatments that we're going to implement and also addressing the research concerns that farmers have. And the Discovery Farms program gives us another opportunity to continue working with partners that we've worked with in the past. And some of those include the Vermont Agricultural Water Quality Partnership, the Franklin and Grand Isle Farmers Watershed Alliance, and also the Vermont Association of Conservation Districts. Next slide. And so just to paint a picture for you all, our research site is a paired watershed, and we're using edge of field monitoring. And so we have 4 micro watersheds on this field, and 2 of which we're doing edge of field monitoring on non-tile drained land. So we're just looking at surface runoff. And then we also have 2 tile drained sections where we're looking at surface runoff as well as subsurface runoff. And we're using that so that we can compare conventional management practices that farmers in Vermont are already implementing and comparing that to best management practices on land with and without tile drainage, because tile drainage is a really important part of the agricultural landscape in this area. And working with our advisory board and those farmers, we've developed, for our research focus, we wanted to focus on cover crop termination and manure management, because that's what farmers were really interested in learning more about. And so specifically for cover crop termination, looking at tillage versus roll and crimp strategies, and for manure management, looking at broadcast versus injection and seeing the impacts that that has. And once we start treatment implementation, we're going to continue to monitor water quality, soil health, and crop production, because the crop production aspect is really important, because in the end, what really matters is how the yields look compared to what they were doing before. But so we're looking at nitrogen, total phosphorus, dissolved phosphorus, and the soil loss on the fields as well. And Joshua kind of mentioned this, but our timeline, the site was installed back in 2020 in the fall, and then we started to collect calibration data, had the drought last year, so there was a limited amount of runoff events, and we're going to continue to collect calibration data through this year so that we can implement the treatments in 2023. And then one of the biggest pieces is the outreach, the ongoing outreach that is one of the pillars of the Discovery Farms program. And on the next slide, we have an overview of our project site. So we're able to do this project on a large field scale, but we can also have the different plots. So we have 2 tiled sections and 2 non-tiled sections, and it allows us to do the plot by plot research, but on a field scale.
Great. So that, unless Joshua, you have anything else to add there? Nice work, Ivy. We'll conclude our presentation and put up our website, and want to thank everyone again, and excited to be a part of the National Discovery Farms program. Thank you.
Awesome. Thanks, everybody. That was really great. We do have a couple questions in the chat for you all. So the first one is, and you guys can decide who takes them. You can fight amongst yourselves, right? So based on your data and experience, roughly how many years does it take to see yield improvement in corn with winter cover crops?
Well, I'll tell you about my first year cover cropping. Well, first I'll say it depends, right? Isn't that the extension answer to everything? But the first year I started my cover crop work at UVM, I was working with a farmer down in St. Albans Bay. I kept begging him to try cover cropping. And finally he told me he said he would try it if I stopped bothering him. And I was like, okay. So he planted the cover crop, and the next spring was so wet and the cover crop grew and it grew. And I had to stop driving by because I was worried that he was going to come out and yell at me. But it was a wet year. He did get the cover crop worked under. He was still using tillage at that time. He was really angry about it. And that fall, I had the nerve to stop back, and he said to me, I asked him if he thought he might do it again. And he said, I don't know what the yields were, but it was the best corn that I had. And so I think the time frame can be very short depending on the initial soil conditions. But it's really about figuring out how to manage it. You know, I think the yield boost can happen quick, but you can also have disasters pretty early on as well.
Great. As we go through these questions, you guys will see that another poll has been launched. So you're welcome to continue to listen to answers to questions and also answer that poll at the same time. That also helps us with our reporting that we need to do to continue to improve these offerings as we keep trying to provide really good information as a group to you all. So you'll see that poll question. So Heather, there's another question about what have you seen? Have any farms using frost seeded clover because of that difficulty in having covers over winter? Anybody using that by you?
I would say that winter rye mostly reliably overwinters. And again, it depends on how late it's planted and all that kind of jazz, but that we have good success with winter rye. We do have a number of farms interseeding winter terminated cover crops like oats and radish and annual ryegrass here. And that's largely being done to try to manage the workload in the spring, the termination workload, so that people, it gets winter terminated and people are able to go out and get in the fields right away. And they don't have as much overwintering cover crop to deal with or manage. But we don't see a lot of frost seeding of clover, not in cornfields. There's not enough time there for it to really grow and amount to much.
Yeah, we see some similar things in Wisconsin. All right. Question about how much low disturbance manure incorporation and strip tillage is implemented in Vermont.
So as far as strip tillage, you know, we had a push from a few farmers 10 years ago, maybe 12, where they were really interested in strip tillage on the heavy clays. And that kind of dissipated and people really started moving right to no-till. Once we started, again, just listening, thinking about the challenges, and able to help farmers address those, especially from an equipment perspective, which I think somebody had mentioned early on, and that's really Jeff's bailiwick that isn't presenting today. We've seen quicker adoption of no-till than any other kind of sort of strip tillage practice. And then as far as like manure injection, as an example, it's gaining. You know, a lot of fields in Vermont are rocky. It's really difficult to do something like injection, but it is gaining here as well. Certainly on the increase, but more expensive. You know, some other barriers there.
All right. One question about, since you observed a drought year in the first year or so, have you considered extending the calibration period? How do you plan to handle that?
Yeah, I can answer that one. You know, I think we're definitely extending it through this year. We'll have 2022, and we're just going to have to reassess at the end of the growing season. We're crossing our fingers and hoping for really active year in terms of hydrology, and we were able to get lots of data, but we just won't know until we have our data and we can look back at the strength of the calibration, and then we'll have to make that call then.
To be continued.
Yeah.
Let's see, questions about tile in Vermont. How confident are you in the estimate of tile drained acreage in Vermont? And wondering what the criteria are for tile in Vermont. Not maybe that makes sense to you all a little bit more than the wording there. I'm not sure.
We have regulations around installing tile. Is that might be what people are talking about?
Yeah,
And
perhaps.
how they're managed.
Yeah.
And that's part of the required ag practices now. And it also has to be sort of evaluated within a nutrient management plan. It is a part of our phosphorus index as well. So there are criteria. You know, there was a time where we thought it would actually be banned in Vermont, new tile. And there was a lot of work done, especially given the fact that with the climate changing so rapidly here, the need for tile has increased even more so than prior. So a lot of work was done to make sure farmers could still use that important management practice. So, but there are regulations.
And do you feel like the estimates of the amount of acreage in Vermont that are tile drained
Confident do
are
we
pretty
feel? Well,
close?
nobody wants to tell you. It's like, I don't know. I mean, I saw that number from you. I was, wondering. You have any?
That was from the census, the 2017 census. So
It's not very clear in Wisconsin either. There's I mean, like at least in Wisconsin, we've got way different uses for tile than like in any of the I states where there's just tons of pattern tile. You know, here in Wisconsin, there's like a lot of pockets that are tiled, and that's much harder to really be able to quantify. So we get it. And then lastly, last question that I see posted here is, do you have plans to look into soil food web or soil biology through your Vermont Discovery Farms program?
So we are monitoring some aspects of soil biology through the soil health measurements that we're taking. It's not extensive, you know, we're looking at respiration and active carbon, potentially mineralizable nitrogen. And we have also started doing some new tests using these eco plates, they're called, looking at various carbon sources and what's being eaten from the different soils that we're looking at and treatments. And we have had interest in digging deeper, and we're trying to get some funding for that. That hasn't been secured. And also looking at other aspects too, like pesticides and neonics and things like that.
Never ending, right? Well,
Yeah.
I will really appreciate all of the presenters from Vermont and all the presenters that we had today. Thank you so much for your time and putting together what I felt like was a really information-rich webinar. So we've gotten to the end here. A few more housekeeping things for you. First, we're going to, Erica is going to put up the CCA credits. Now there are 4, to get all of the CEUs that are available for this session, there are 4 different pages you need